Hello, 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 hello. Good. Cassandra. Around in
Yeah, that should be fine. Okay. Friends, we have now Dr. M.V. Rajahmundry ji. He is a distinguished scientist H and currently serves as the mission director of the Deep Water Mission under the Ministry of Earth Sciences, Government of India, New Delhi. So he has excellent career. Dr. Murthy's experience bridges science, innovation, and policy for the development of blue economy strategies. So he has a lot of things to. I have a lot of things to speak about him, but because of time limitations, so I request him. You can verbally start. In the meantime, they display your PPT.
Very good morning to all. Welcome to Taiwan. And this meeting is based on their presence here. But heartily thank you all the faculty for and chancellor, everyone in TTU. This is my second visit to TTU. I think my purpose of coming here is only to have interaction with TTU, how we take the TTU, we give it better options, especially on the research and innovation, but also to look for more opportunity of TTU with joint collaboration in Taiwan, and also with national sciences. I come here last time, I think, I want to spend more time, but today I think I have to go rush immediately so that that's the meeting. But once again, I thank you for providing this opportunity, and then we have a short presentation, and then I'll look at and see where we can do our collaboration, especially with teaching it more at national level and international. So this is, I think, the title of my talk. Unlocking the blue economy, basically on the deep mission. Though the deep mission has been launched from the working on the ocean. But we have the colleagues in GTU to work on. In fact, we have a collaboration not only from the India but also with our countries. In fact, my first experience with IPs, I'm supposed to give some talk in tsunami way back in 2008, but I can't go. But I think we had a couple of opportunities working with Airways colleagues and we are working with the project of the Pondicherry. So this shows about the maritime unit, which is very common for Taiwan also. Right now, most of the activities are restricted only to technology. That means it is up to 1 nautical miles. But now we want to expand our activities in exclusive economic zone, that is up to 1 nautical miles. Also on the high seas. That's how this remote mission was launched by the Ministry of Agriculture. It doesn't mean that we work on the ocean, but we work on all the disciplines, especially related to the research and innovation. This shows about the objective of the government policy, like what we have in the area. But if you look at the major component is to prioritize the goals on the biodiversity, which is one of the important areas, and also have an inclusive growth. That means society plays an important role as a part of the economy, and to promote investment in the sustainable development in infrastructure. The last component is encourage innovation, R&D, and technology adoption. This is where GGU plays an important role. I think for today's conference, what we have been discussing for last 2 days, universities are the better places where we can promote innovation and research and technology. Coming to the emerging sectors, I think GGU, though it is slightly away from the coast, but we have a place called Kakinada, which is almost like somewhere around 20-35 kilometers from here, and then many activities are there at the Kakinada port. We have activities related to the tourism. This is common for our fisheries, and then conservation and protection is one of the important components of the blue economy. More importantly, maritime security is one of the major areas which is very common for India and Taiwan. Also on the offshore, what technology that we are using. Last part is about the mining. This is very important for the future to get into minerals. I think you all know for that Taiwan is known for their excellence in the semiconductor, especially industry. In fact, India is also looking for more cooperation from Taiwan in this area. But how this will be useful in ocean sector is basically on underwater robotics. If you want to work on that, Taiwanese police got a good expertise, and then that is where we can collaborate. In fact, GG also should focus more on the underwater robotics. This is one of the new frontier area for the future generation. We have almost like the 9 pillars of the blue economy. First one talks about the accounting. How much of ocean contributes to the global domestic product? Right now, we say almost ocean sector contributes to 4%, but we want to increase the number to double digit, at least more than 10%. We need to map a lot of areas in the ocean coastal areas, because once we exhaust minerals in the land, we will go for the sea. But there are some concerns related to the environment, but also on the mapping of the sea, and then what are the economic potential of the ocean. And ultimately, leaving all those things, I think it is about the innovation and R&D and technology adaptation. What we need. This shows about the mapping of the each of India, which was done by the Ministry of Earth Sciences with various institutions, and almost the entire east coast and west coast was mapped as part of this exercise. Coming to the new coast mission, it was launched in September 2021 by basically to explore and harness the ocean resources. They got almost 7 pillars. First pillar is about the deep sea mining and land surface. India, I think you might have heard about it in Chandrayaan, people will go to the moon, but in the Samudra, we will take 3 people down up to 6,000 meters further. That is the one of the major objectives of the new mission. Second one is about, you might have seen, ocean climate advisory services, because 70% of the climate is controlled by the ocean. That is why we need to concentrate more on the either floods or cyclones. All those things are getting increased. How do you manage and how do you adapt ocean climate change? Third one is about the exploration conservation of biodiversity. It has 2 applications. One is about the mapping of biodiversity in the ocean, same by the land, but also to develop molecules especially for pharmaceutical, nutraceuticals, and also for the many applications that comes from the molecules that are being collected from the deep sea. Fourth one is about the deep ocean survey, which talks about the polymetallic knowledge which is available in the deep ocean, and also on the hydrogen sulfide cells. What essentially it gives is we all know about the critical minerals, especially on the present era of electronic or electrical vehicles. For that, you need to have some of the critical minerals will come from the ocean. How do we extract and how do we utilize these minerals from the deep sea for the new industries that are going to come from? Finally, about the advanced marine biology stage, where we have more focus on the biotechnology component of that. This is where I think GG should take a part in that. In fact, in the map which I showed in the subsequent slides, almost all the institutes are there. Last time only I was mentioning about that GG should take an important part in the biotechnology part. This shows about the potential sites of the Central Indian Ocean manganese nodules, where we have manganese, cobalt, nickel, and same thing for the hydrogen sulfide, which also gives a critical mineral which is useful for the batteries, especially the polymer battery. This shows about the composition of minerals that we get from the Indian Ocean. India has signed a contract with them. This contract is going up to the 2027, but right now we are in the phase of developing a technology for harnessing these resources in sustainable way. Coming to the development of technology for the land successful, on the right side picture which I am showing here is the development of manned submersible or human submersible. In that, almost all the critical components have been completed, and then we are almost completed the harbor trials in the of Chennai. Hopefully, by beginning of the next year, we will be going to the final water. Right now, people have been taken with French Nautilus submersible up to 5,000 meters, but we will be going the same thing in India also. This shows about the human submersible, how it looks like. It goes up to 6,000 meters, and it can take 3 people down into the deep sea up to 6,000 meters. It has an operational time of 12 hours, but in case there are endurance, in case of any accident, anything comes further, it can survive up to 96 hours. What it means is you have oxygen supply and all things for operating for the 96 hours. This design is complete, and also we have completed the integration that first set of trials have been done, but future we are going to do further piloting and then slowly go to the 600 meters. This is one of the major first area of the Ministry of Health Sciences, which is implemented through the National Institute of Ocean Technology. I have a video, but I think maybe I think this video here how human submersible operates in the system. Just quickly operates it. Only water will be filled. No, I mean, maybe you can see the video. I just go to that. This is about the ocean climate advisory services, where we are going to predict how the future cyclones or floods, what we are going to get in the Indian continent, and then ultimate aim is to prepare coastal environmental map at a scale. Hopefully, we will be ready with the first development map will be ready by next year. You would have FGAs to really visualize and then see what kind of hazards that we are going to get and how to mitigate these hazards. These are some of the timelines what has been given, and then you can see from the Earth Science website most of the things are already in progress and will be delivered. This is the picture I think most of you might have seen. This is Gateway of India and Mumbai. During the normal time, you can see on the left hand side. During the high tide, how it looks. But if you have some small storm itself, you can see on the top how does it looks like in the Mumbai. But what is going to happen for the future is this. Not only Mumbai, in many of the areas, especially Delta areas, even Godavari also, we may have such kind of problems in the future. Then how do we mitigate? So we have developed a prediction system and then see what kind of sea level rise that we are going to get in different parts of the Indian coast, Bhavnagar, Mumbai, and islands, and also in Vizag and Paradip, and what are the intensity of the sea level rise and cyclone which is going to affect these coastal areas further, and how to mitigate and adapt for such kind of event. This shows the map of, in case if there is a sea level rise, how many areas are getting inundated. In fact, you have to little bit more worry about both East Godavari and West Godavari. These are the main flood-prone areas, especially when you get sea level rise and then followed by the cyclonic intensity of the storm. There are many reasons for the erosion of coastal areas. I think the people sitting here are all from the place called Upada, which is gradually getting eroded. That right now we are working out a intervention and then see how we protect the Upada portion of the sea erosion. This shows the coast of Upada. I think most of the people from here they may be aware of that. And then through NDMA, almost like 250 crores project, I think, which is already at the final stage. Hopefully, we will get that, and then this village will be protected using the solution which has been developed here. And similar thing which we have done in Kerala also, and then right now I think almost last 3 years there is no flooding and erosion in Kerala for not only restricting to that. This is what I was telling, which I was working with tsunami with Taiwan. We have prepared a environmental maps and also at sea level maps. This expertise which is available in India also can collaborate with Taiwan. Put it specifically on some of that flooding and tsunami related things. In fact, I was working with tsunami board for more than 6 years in Hyderabad. And this shows that if we have a vulnerability in terms of sea level rise, storm surge, and cyclones, how they in every part of the coast is going to be affected by that. This kind of extreme events have been mapped, and then these maps are available and shortly by the next year in website, and then it can be taken by. Ultimately, how it looks is we have a city. This is the Delta in Nagapattinam, which was badly affected by the tsunami. In case if tsunami acts, what are the areas that are going to be inundated, and then how do we mitigate these things? Not only restricting only the harsh pollution, we have put a one area in Pondicherry, like you might have seen that stone wall which is there on the coast. We got back the beach using a technique called some innovation. A submerged reef was inside the sea. That helped in reducing the wave activity and then getting back the beach. Such kind of solution should be seen for the even for Andhra coast also, because it is unaffected in most of the areas, and then we need to prepare ourselves for such kind of innovative solutions in the future. The other one about the deep sea wide industry, as I mentioned earlier, we asked 2 applications. One is about inventarization of deep sea wide layers. Second one is do the metagenome analysis and then see these molecules which can be used for the pharmaceutical and then medical application. This particular component we are working with CDI, you might have known about certain reasons issues for that. Ultimate end molecule will be developed by CDI, but basic molecule will be corrected by us from the deep sea. We correct the molecule from the deep sea at the low, high pressure and low temperature. This will be subjected to the screening analysis. As I said earlier, we will also do a lot of survey in the deep sea about hydrogen sulfide and PMN, and then this map shows what kind of mapping that has been done by the sciences of the National Center for Polar and Ocean Research, and this will be used for the harnessing the resources of the deep sea. The last part is about we have to have water and the important problem of the future. We try to use the ocean energy thermal conversion, where we use the gradient in the ocean to convert get the power from there. Same time, we use the environmentally friendly technology called water thermal desalination to harness the water and then convert the seawater into fresh water. This shows some of the work that we have done in Lakshmi Islands. Almost 900 desalination plants are there. Here, what we use a different technology, not like conventional RO technology. In RO, we use the memory, but here, what we use is we evaporate the water on the vacuum and condense using the deep sea cold water that is drawn from the water depth of 350 meters. That means there is no price in this technology because we take only 1%. And similar is the case with the desalination using the solar desalination. This is one of the important applications which can use in many of the rural areas. Offshore wind. This is the way I think in Gujarat and then Tamil Nadu we are going this further. Hopefully by next year we will launch that offshore wind projects in Kanyakumari, where we can use renewable energy to power our mainland. The last part is advanced mineral biology station. This is where biotechnology plays an important role, and many universities and then academic institutions are also part of it. What we use the hub and spoke model. Hub will be there in Chennai, but all the sports can be there on that. Ideally speaking, I think GG also can be one of the spoke model which can be anticipated in the future and then see how GG can take part in the system. This shows about the number of organizations or institutions which are taking part in the deep mission. It is not only covered for the southern India but the entire country. You see the map of a pan India. Many institutes are involved on this. Right hand side you see the number of institutes that are working on that. So it is unfortunate that GG is not part of that. I think they have missed some work part of the proposal. Maybe we have a future opportunity to take up this in the future. And finally, we consider coastal ecosystems and then how do we conserve and then protect these wetlands and all which is important for the system. That would be one of the main components of the economy to develop in a sustainable way, but same time will protect the wetland ecosystems and all things and other coastal areas. So we had a framework for implementation of this one is called as parent spatial planning. Right now we have been doing on the coastal areas, but we will be going into the deep sea to see how do we conserve and then protect the marine resources. This is the concept called parent spatial planning. This is what is called as the CRZ. Most of you are known about the coastal integration zone. We are extending this to the deep sea and then see as a parent spatial planning how do we do it. So this is the last of I was telling you that only we had no beach in the past, but now we got the beach on the Pondicherry. I think similar things should be done for Andhra coast, which is not much affected by the many of the development activities. This is the right time to open our eyes and then see how do we adopt innovative techniques for restoration of our woodland and protecting the people along the area. The same thing is here. Thank you and thank you for this opportunity.
Thank you so much, sir, for your enlightening presentation. Now I would like to request our assistant chairman, Dr. R.S. Raju, sir, to kindly felicitate our esteemed guest, Dr. M.V. Rajahmundry, sir, as a token of appreciation and honor.
I now request our executive chairperson, Dr. R.S. Raju, to kindly introduce the second eminent speaker of this session.
Yeah, our second speaker is Dr. S. Sivaperumal. He is a pro-vice chancellor of Presidency University, Bengaluru, where he plays a pivotal role in shaping academic excellence and institutional growth. A distinguished academician, he has contributed extensively to higher education through teaching, research, and administration. With rich experience in fostering innovation and interdisciplinary learning, Dr. Sivaperumal is dedicated to building dynamic academic ecosystem. His mission emphasizes education, industry collaboration, and engineering for future ready graduates. So I request you, sir.
So, good morning, all of you. So, I think you are hearing a lot of technical sessions. Probably I thought I prepared some different presentation yesterday. After seeing the crowd, more students, I little changed my presentation, which suits more students. Maybe probably I may be doing something like I want to introduce Taiwan to most of you. That is my job. What I thought. I think all of by end of the presentation, at least some of you should get inspired to go to Taiwan to get some opportunity. That's what I just changed my presentation. Even though I started my presentation to focus on 3 different SDGs: SDG 4, which is quality education; SDG 9, which is more industry innovation infrastructure; and SDG 13, which is more on climate action. Probably SDG 17 is partnership for goals, but I'm going to restrict myself to quality education. So I think I am further breaking down the quality education, how it can be achieved through the internationalization, how getting a lot of international opportunities or quality education can be improved. I think what I believe, which most of you will aware, by having quality education, definitely we can do a lot. Maybe whatever we talk about, all the other SDGs, which will be very easy. If students are aware of what they are supposed to do, I think probably our job becomes a little more easy. So maybe I will little introduce me so that, see, I always claim, maybe I say I claim, I closely work with the Taiwan institution for more than 12 years. Probably thanks to Professor Yang, thanks to VC sir, Professor UC sir for giving me this great opportunity. I think I have been working with Professor Yang as well as with Yu Chandrasekhar sir for more than 10 years. I am very closely working with both of them. So we had a lot of outcomes. As Chair introduced, I represent a university called Presidency University in Bangalore. Maybe what I want to do is, why I am emphasizing that is, Presidency University is another very small university, maybe comparable to GGU probably. We are not like an IIT or NIT where only high quality students get into the university. It's not that way. Probably the student level is very much comparable. What you are here, I have similar students at Presidency University. Why I am giving more emphasis on this part is, there is very good opportunity for all of you to go to Taiwan with a very good funding support. That's what I wanted to make. Let me give you some images so that you will believe what is. Yeah, see, I visited closely work with Taiwan. I visited 15-20 times Taiwan. Probably, maybe I would say, I always tell my friends from Taipei to Pintu, probably, or Kaohsiung. I visited most of the cities, all the universities. I have been visiting Taiwan for more than 12 years, very frequently. As I said, thanks to Professor Yang for the great thing. You can see, maybe most of the universities who came, Malaysia University or Taiwan, I've been there to most of the universities. Sun Yat-sen University, who's a core organizer. Even I've been closely working with Sun Yat-sen University. And other thing which I would want is, maybe you can see our UC sir. I purposely added this photo. Probably our Yu Chandrasekhar sir, when we worked together on same day, we signed some 8 MOUs with Taiwan universities in the presence of Higher Education Minister of Taiwan and Ambassador. I just added this slide just to say how close we can work with Taiwan institution. And probably, see, here you can see we hosted the Taiwan Fair in 2017. Maybe a lot of universities came to our campus. And I will add, as I said, Presidency University is the first university to set up this Taiwan Education Center. I think when I met the Chancellor yesterday, I also insisted you should also set up Taiwan Education Center so that students can learn Mandarin Chinese so that they will get a lot of opportunities in Taiwan. So we are the first institute. You can see the Ambassador of Taiwan in our campus who inaugurated the Taiwan Education Center. Who is our Chancellor, all those. I think another thing is, maybe as we say, you can see that this is the Karnataka's first Taiwan Education Center. And I also somehow, maybe I frequently meet the ambassador, maybe I very closely work with them. That's what I'm trying to say. This is about me. Maybe one more important thing is, I think I had a honor of hosting the Taiwan Job Fair. We saw NVIDIA, Realtek, you can see yesterday Delta Electronics were there. So we hosted the job fair of all these companies in Presidency University. And you can also see the top 3 universities from Taiwan. All the National Taiwan University system were in our campus for a family at our campus last year. I think it was the end of December. Just review. Okay, now I come to the point. I think straight away I go. It's more beneficial to students. Probably maybe may not be much useful for others, but I'm more focusing on the students. As I said, I thought of covering 3 SDGs: quality education, innovation, infrastructure, and climate action. But I would restrict myself more on quality education through internationalization. So that's the major focus which I will be talking about. So why Indo-Taiwan is more important for me personally? Also, it's very important for me. Again, I had 2 Indo-Taiwan projects which I coordinated from Professor Yang as well. So that's one. And you see, if you look at Taiwan, I think, can any of you name some good products came from Taiwan? You heard any of the important products came from Taiwan? Any of you know some important companies coming from Taiwan? Yes, sir. Chips. Chips is very generic. Any specific product? Some laptop? Yeah. Probably the Wi-Fi devices use D-Link, right? D-Link. There is a familiar Wi-Fi device, right? And I think Acer laptop is from Taiwan, right, Professor? Acer laptop. Yeah, Foxconn, who makes an iPhone manufacturing, right? Who are the major manufacturer of iPhone. See, many of the Taiwanese companies we are working with every day. We use a lot of their product every day, but still we think Taiwan is a very small country. They are not much. We always think US, UK, Germany, France are our international aspiration. But Taiwan is one of such a beautiful country, very safe. In terms, they are very friendly people. So I will give you one example. If you just go to Taiwan, you walk in the street, you ask for a way, how to go to the place. One difficulty is they may not communicate well, but the intention behind, they will take you to the place, drop you, and then only they will go. That is the kind of people what they see, why I am telling is, as a student, whether it is boy or girl, you don't have to worry. Come very safest country. I think they are the safest country in Asia in terms of safety aspect, right? Very disciplined. They're very kind. The people are very kind with the people. So I think why I am telling is, as a student, you all should make use of this great opportunity of the presence. I think thanks to you, sir, for bringing such a great conference to GGU, where you get to know Taiwan. I think for the last 2 days we have been talking about more Taiwan. I don't know how much you got about Taiwan University. So as I said, I will be more talking about Taiwan opportunities what you have. Probably I will go there, right? So what is why Taiwan? I think TSMC, Taiwan Semiconductor Manufacturing Company, is world largest semiconductor manufacturer. I think 50% of semiconductor is manufactured from Taiwan in their world. I think I'm proud to say many of my students are working for TSMC who are from India, who studied in a similar university of GCU, like Presidency of Wellcome, where the 2 institutions where I served. They studied from those universities. Now you think of they are working in TSMC. The students are working in Cadence. I know the electronics students will know. The real estate design tool is a Cadence. Many of my students are working in Cadence, TSMC, Delta Electronics, Realtek. I can name a lot. All these are possible just because they choose to go to Taiwan for a small period of time. That made their life completely change. Right? I always advise the students. See, I think initially making you to understand how good is Taiwan opportunity is a little hard which you should understand. One thing is Taiwan, as I said, safety, all are first. Next thing is, see, many students now, when somebody, for example, there is an opportunity called IAPP internship, which I will talk a little later. There is an internship called IAPP, which is from the Ministry of Science and Technology from Taiwan. They give internships to students for 3 months. They pay around 30,000 NTD per month, which is equal to 82,000, right? I have more than 200 students who use this internship to go to Taiwan in last 2 years alone. More than 200 students. So I think that is one of the opportunity which you all should explore. When we say that university is paying you 80,000 per month as a stipend, what do you think? No, it is not for me. It is for the students of IIT, students of IIT, very good students only can get. No, it is not correct. That's why I said I work at Presidency University, which is similar to GCU in terms of students quality, right? These opportunities are not restricted only to IITs. Any students can get into these opportunities. That is what I'm trying to say. See, when you think, no, when you are given an opportunity to go abroad like Taiwan, you always feel I should have high knowledge. They may ask you to do on day one some good job. Nothing like that. They will give you enough chance. They will train you a lot. But only thing what is expected is you should be passionate. You should be hardworking. You are not supposed to have very good knowledge now. You go there, they will teach you how to do some practical things. Again, you are not going to book by book. You are not going to again study the books. You are really going to have hands-on experience. That is one important aspect of Taiwan, right? So I think as I said, it is. You can see the TSMC, MediaTek, Foxconn, these are all top companies. Also, you look at the universities. See, in India, the highest ranked university in India is IIT, maybe Madras or IIT Bombay or IIT Delhi. They are in 150 range in the world ranking. But if you look at Taiwan, NTU is ranked in top 70 in the world, right? So there are many universities which are ranked in top 100. I think if I remember correctly, there are more than 10 universities from Taiwan which are ranked in the top 500 in the world ranking. So they have very good universities. There are a lot of national universities. I think that is one of the another aspect. And I think see, yes, I will talk about this. This is the important slide which I want to cover more. I think how as a student, what are the opportunities available? As a student, number one, there is an internship called TEP, right? Taiwan Education Experience Program. You can search TEP Taiwan in Google. Probably 5 minutes I will show you the website just for you to know. They have given a lot of internship opportunities to go to Taiwan. You can search the project, the topic of the project. Probably Professor Yang, maybe there are other professors who came here. They are all having the project in the team program. Through team program, they will be inviting you for 3 months, 4 months, or 6 months. They will be paying you completely, right? You will be doing a practical work. Again, you are not going to have English knowledge. You are going to have a lot of practical exposure, right? Right there you can search TEP Taiwan. That is one of the great opportunities which all of you can explore, right? They have given hundreds of projects. You can choose from projects in AI, projects from medical, projects from healthcare, projects from environmental. There are a lot of projects which are there. I think by looking at the project, you need to little prepare and contact the professor to get this internship. This is one of the great opportunities which all of you can get. And the second opportunity is IIPP, right? Which is not only from universities, it is also in some R&D organization like ITRI, which is in Senchu, right? So I think, see, there in the team, the stipend amount varies from 10,000 NTD to 15,000 NTD, right? You can always calculate national Taiwan dollar is maybe 1 Taiwan dollar is 2.25, 2 rupees 25 paise. You can multiply with 2 just to have a calculation. So they pay around 15,000 NTD. It means easily you can get per month 35,000 as stipend per month, very easily. But in IITP, they pay up to 30,000 NTD, which is equal to 82,000 per month. Many of my students got this internship. It is nothing great, right? It is a great opportunity, but as I said, you should be very sincere enough to learn things when you go to Taiwan. Your attitude is very important. What knowledge you have is next, but how you are going to contribute to the professor is very important. As many of the professors have been telling, they offer master's program. You can see that's the third one, right? There are a lot of opportunities to pursue your master in Taiwan University. When we think of masters, I know a lot of undergraduate students go to US. They just go to US for pursuing masters, right? But you pay a lot. You pay maybe 50 lakh rupees as a tuition fee. You spend a lot of money for living. But in Taiwan, lot of universities offer 100% scholarship. It means you will not pay any tuition fee in many universities. I am not telling every university. Most of the universities have been offering full tuition fee ever for pursuing your masters. Plus, they pay you a monthly stipend. Not just a scholarship for tuition fee, they pay a stipend per month. Many universities pay 10,000 NTDs as a very normal thing. And another opportunity is MOE scholarship, Ministry of Education scholarship, right? They announce every year MOE scholarship at the month of, probably in the month of November, October, November, right? They announce the scholarship in the end of December. The scholarship deadline is till March usually. The scholarship is given to students for pursuing masters or PhD. They will give you complete tuition fee from the Ministry of Education, plus they pay a stipend of 50,000 per month for pursuing masters, not working. Please understand, for you to pursue masters, they pay around 50,000 per month as a stipend, just for pursuing masters. I can name many of my students got a scholarship in the previous week, right? Again, I am telling, the students are not from IIT, NIT or top universities in the world. They are similar to you, right? The university students are similar to you. It is very much possible, right? And I can connect with many of my students, especially who are from Andhra Pradesh, right? I can say students who are from this region. I can connect with some of the students who studied 12th standard from this district and came to my other universities to pursue masters. We can connect. There are a lot of success stories which I can easily connect, right? Why I am telling all these are, it is possible for anybody. Don't think the students have to be from only from IIT, nothing like that. Any university student will be able to get these opportunities, right? So I think I will not talk about this team I covered. This is a website team.study in Taiwan.org. That's the website which you need to go through, right? You can just search team Taiwan, you will get the web link. Just for you to give a the web link. Team.studyintaiwan.org is the one website. And the next website is IIPP. I think the website is IIPP.edu. That's the website. You will get the project list. You don't have to do much of work. The project list is available. Just need to find out which project you are interested in. Contact the professor to get this opportunity. Right? So I think masters. I think which I already covered most. And one more thing is the Ministry of Education gives another scholarship for you to learn Mandarin Chinese. Right? You want to stay for Taiwan for 6 months just to learn a language, they have scholarships called Bayou Enrichment. They have a scholarship from Ministry of Education just for pursuing your language learning in Taiwan. You will go to Taiwan, learn the language, and come back. Right? I think I can give a number of examples. So many of our students went there. Even you can search in YouTube Presidency University channel. Then you will see a lot of students who went to Taiwan talking about it. Right? I can give you a classic example with the name. The student name is Goswami. She went to team internship and then she pursued her master's in Imperial College in London. She always said the internship gave her the opportunity to get master's in Imperial College in London. Imperial College in London is number 1 in one of the ranking, number 2 in another ranking. The QS the burger ranking, right? She did master's in surgical robotics. You can think she is a computer science student. She went for a medical application team program in Taiwan. It turned her to be a master's in the medical field, right? Surgical robotics, master's in surgical robotics, right? She's working for a very big hospital, even though she's an engineer, right? So that is one of the classic examples. Like, if I can give such a number of examples, right? Who are working in TSMC, who are working in Foxconn and all those. So I think my job is that how I think I want you to believe Taiwan is a great country for you to pursue an internship as well as for your masters. That's what I wanted. Probably I could cover partially. Any doubts? I think yesterday when I met the VC sir as well as Chancellor, we spoke a lot about it. We will do a lot of sessions, similar sessions in the same way. I think at least some 20-30 students from GGU should go to Taiwan to do some internship in various other countries. Right? So I think I both the presentation you have, I have lot of slides, but I'm not going to run through. One more thing, just for the professors, I understand I think there are a lot of case studies which Indo-Taiwan worked jointly. A lot of case studies are there. I'm not going to talk much about it. I will cover only one aspect. Yeah, for faculty, I think Professor Yang covered yesterday. There is Indo-Taiwan call. I think that July 31st was the last day of this year. It was over. Probably we'll expect the call in the next year as well. Every year you get a call from Indo-Taiwan, Ministry of Science and Technology from India and Ministry of Science and Technology from Taiwan, NSTC, which Professor Yang represents. They come together and call for a proposal. Every year they give a funding for 15 projects. I think who knows, the professor who came could be one of your collaborators to work with and get some project, right? So you can see the area almost AI, IoT, medical application, environmental areas can be very easily predicted. Nothing like very surprising area. Agriculture is another area sometimes used to get. Here it was managed by an agency called ITA, Global Innovative Technology Alliance. Now it is I think sometimes it is IAE, also there is ICSSR. There are two different calls which comes in a year. One joined with IAE, one comes with ICSSR. Right? So you can see the areas like artificial intelligence, IoT, big data, cybersecurity are very common, and other areas includes energy, healthcare, biotech, and all those. Right? So I think I will close with this. Thank you very much. If anything, I will be happy to interact. I'm able to justify the time. Thanks.
Some more few 1 or 2 minutes, no problem.
Okay. No, I'm ready. Maybe probably what I will try to. Sir, can you give escape? Sir, can you give escape? I'll just go to the website very quickly. Probably go to the browser. Yeah, this is the key website. I will tell you how to find it. Right? You will see a lot of. So you can see the programs, the research areas where the internship opportunities are available. You can search exactly in which area you want to do. You will see business management, you will see engineering, right? If you think engineering, you will get through all the topics, right? Which university, which is the date, all this you will see. You can directly contact the professor if you think any of them. I don't know whether. Probably I will show Sanyansar because the professor, I think one of the partner of this is Sanyansar. You will see the title, AA Robotics for Agricultural and Forestry Survey. You will see who is the contact person, how to apply, all and get the information. So minimum 3 to 6 months, they will pay you full. They will pay you every month stipend. You will get an opportunity, right? And just start so that you can get prepared for going to Taiwan by applying some kind of internship. You will get full information. Like this, you can go through any of such an internship and get. You will see the list. Hundreds of projects are listed. But it's up to us how to use and make use of this great opportunity, right? See, I'm telling you, I promise you go to Taiwan for short term, and very sure you will go back for your masters and PhD, right? That's one of the great what I have seen, right? I have nominated more than 1,500 students in last 5 to 6 years alone. More than 1,500 students in Taiwan alone, right? There are great opportunities which are available which you will explore automatically once you go. So that's all from me. Maybe I have not done justice in terms of technically talking, but I thought students will be benefited through this session. Thank you, sir.
Thank you, sir, for your wonderful presentation.
Students, you have seen how informative his presentation is. You have a plethora of huge opportunities. And he mentioned that Taiwan is a very safe place. You should now time you should explore those. And we have Taiwan experts. They all from Taiwan, spending 2-3 days. So you can imagine their courtesy. You will have good opportunities, very good opportunities.
కదులుతూనే ఉంటారు నేను చేస్తాను. అదే కదా
Thank you, sir. Moving ahead. Respected chairperson, Dr. Alex Raj, sir, to kindly introduce the third and final speaker for this session.
Yeah, we have a third speaker, Dr. Spurti Singh, a senior assistant professor in the Department of Mechatronics Engineering at Manipal Institute of Technology, MEA, Karnataka. She is actively engaged in teaching, research, and monitoring in the field of mechatronics and allied engineering domains. Her academic contributions focus on integrating innovative technologies with practical applications to enhance student learning and research outcomes. With a strong commitment to academic excellence, Dr. Singh has been guiding young engineers in developing future-ready skills. She continues to play an important role in advancing interdisciplinary research and innovation in engineering education.
Good morning all. I'm Spooky Singh. As he mentioned, MAHE, M-A-H-E. So it used to be called as Manipal University before. Now it is being called as Manipal Academy of Higher Education, MAHE. Today I am here to explain you about some of my works. So I want to see the freedom of agriculture, multifunctional. You all might already be knowing about agricultural robotics. We use robotics for agricultural applications like harvesting, feeding, maintenance of the crop, plant seeding, crop packaging, palletizing products, or for greenhouse farming, or autonomous monitoring purpose. So generally you might be seeing some of particular robotic designs which will be for particular task oriented, something like only for seed spreading or for tree planting of the robot, then weeding robot, pesticide spraying like this. Sorry. Harvesting, for crop harvesting or pick and place of either fruits or unripened or spoiled fruits. That segregation regarding or wood cutting fruits. Then processing and also for food processing of the robot. So we have done some of the research regarding monitoring of in-house plantation with IoT application and all. So when we were working regarding this, we thought of why don't we come up with some multifunctional robot designs. So for which we thought of having some real-time problem solution. Why don't we provide, which is having multifunctional options in a robot. So in our university, we observed this thing, if you can see. So every month, at least twice in a month, people used to cut the grass, and there are some people who will be collecting the grass. So this we wanted to automate through some robot device. So we have come up with a problem statement like a robot should be grass cutting, and also it should be crushing the dry leaves or unwanted, the leaves fallen on the ground, those things, and also collecting of it. And if we want to use it for agricultural applications, which should be useful for farmers, for which seed dispenser also must be included in it, like that we plan. So we have come up with something like this design. It is patented as well. So initially we have come up with a 4-wheel bot which can do a grass cutting as well as collecting. Then we modified it. We have attached a crusher as well as a seed dispenser in it. Then we thought it will not be useful on normal uneven ground terrain. So for different terrain, why don't we come up with a little modified wheels with 16 modular road design we have come up with. Then same thing we have attached with that trailer. Then everything must come in one design like that we planned. Finally we have obtained this design. So it is also patented. We have a publication also related to that. So we also did some of the material analysis like on safety factor, distribution, what type of material we can use, all those things for both the designs, 4-wheel and 6-wheel. And internally, because we have combined everything in one, so for suction as well as seeding, so we have provided some of the internal slots for it. So cross-sectional view of it you can see here. And also we tried for the section what type of design would be better. So Z type, X type, and right section part we have created. We did some of the analysis related to this, and we did some comparison to see which one would be better. So the section part will be collecting it where it will get stored that we have shown over here. So now also we can see the mesh deformation and flow direction vector field in that. So this was our first design. Then we redesigned it and made it as one main design component which involves everything within it. And also we have given some attachments to it, like structural attachments or other for soil loosening and grass. Either not only the cutter, we can use a trimmer also depending on the size or level. Then leaf pressure we can attach to it. Also, we have done some ROS through web simulations. Depending on in uneven path, if any obstacle comes, how it will be moving through that. So that was related to one design which we are working. Then other than that, we are working on fortified robots as well for agricultural application. We got a fortified robot from Unit 3 company. So on this also we are working on for agricultural application. Other than that, smart robot also we are working on. We are doing some cross simulations as well as backward simulations related to that. Navigation, it's path control. So with the different algorithms, path tracing, path planning, all those things we are working on. So we have a publication related to that. On its gait analysis and kinematics. So for 4-leg robot and 6-leg robot with different orientations and joint connections, we try to do some analysis with its trajectory planning and comparisons. And also we have made use of MATLAB 16 multibody for its simulation and control aspects like inverse kinematics, forward kinematics, inverse dynamics, forward dynamics, all those things we have implemented in MATLAB 16 multibody with different algorithms we try to control. So it's a trapezoidal trajectory planning and all, we try to do the analysis. Then same support robot, we try to make use of it for underwater robotics by providing a mechanism where we can deploy a wing under it. So we have a collaboration with the new technologies. With them, we are working on this. Means it can work on the ground as well as when water is getting sensed, it will try to swim by flapping its wings. By deploying its wings, and it will start flapping. And we did some hydrodynamic analysis by inside the water with 1 meter depth, 2 meter depth, 3 meter depth where it goes. Then how will it interact with the TPU material we used as a wing material here. And also we try to do some analysis with different 4-5 different materials. Then other than that, same export we again converted into 4 like waterfront robot, and we try to implement and use it for agricultural applications. You can see here at its edge we have connected with different grippers. One for 3-finger gripper, one for suction gripper, and then we have a spiral one, and then a single gripper. Where if we want to cut a plant at a particular level, we can make use of that particular leg of a robot. And if you want to lose the soil, then we can make use of that spiral edge. Then if you want to, let us say, pick and place or pluck any fruits out of a plant, so we can make use of 3-finger robotic gripper here. Then even suction cup for some particular fruits which are very delicate, you can work with a suction cup. So while it is working with one particular robotic leg, it has to balance itself with the 3 remaining legs where it should not be falling down. So that option also we have provided in this. This is also patented design. Yeah. So these are my work along with in mechatronics department related to robotics. Apart from this, I did my PhD in UVM, Malaysia. So I have worked on flapping wing micro aerial vehicle with multiple designs. So mainly on flapping actuation mechanism and its kinematics, dynamic analysis, and also fabrication part. Because of which, regarding that research, I got in contact with Professor Langjia. So currently, I'm doing some collaboration and research with him. That's why today I'm here. Anyway, thank you.
Thank you very much, ma'am, for your fascinating presentation. May I now invite Dr. Indilawati, Dean Academic Affairs, Godavari Global University, to kindly felicitate our esteemed guest, Dr. Smurti Singh, as a token of appreciation. To kindly share his closing remarks.
Next, we have valuable presentations. And all the three. The first one, of course, is Rajahmundry garu on blue economy. He has shown visuals on how a deep water vessel can be handled. You may be aware that in the water, in the sea, if you go 10 meters down, the pressure doubles. For each 10 meters, the pressure doubles. You go 1 kilometer deep, the pressure would be 100 times this pressure, 100 times the atmospheric pressure, 100 times. So you implode. So how to manage the vessel, how to go deep for deep water investigation of various things, minerals and whatnot. So they have a plan to go still deeper, initially to 600 meters and thereafter much deeper. So he gave his plan, which is very nice. Another one is that Seva Perimal garu, anyway, but we are garu means Esquire, means sir. This is the respect we had that comes automatically for a Telugu person here. And he has shown plethora of opportunities. Plethora. I think now the students should explore it. I am taking his PPT. You can also be agreed for any query. He will help us. Third is Madam Subhuti. She has given some of the innovative ideas, turned into practical models, grass cutting to leaf cutting, and robotic house, etc. So all the talks were highly informative. I thank all the speakers.
With this, we come to the conclusion of technical session 4. May I now request, on behalf of the organizing committee, it's my privilege to deliver a vote of thanks to this enriching session. First and foremost, I express our heartfelt gratitude to our session chair, Dr. Rajahmundry, for his gracious presence and guidance throughout this session. We are deeply thankful for our eminent speakers. Each of these talks have been truly inspiring and have provided us with fresh perspectives and sustainability and innovation. We also extend our gratitude to the felicitation team led by Dr. Valli Madhavi ma'am, the volunteers, and most importantly, all the participants for your enthusiastic presence and engagement. With this, we formally conclude technical session 4. Thank you, and we look forward to meeting you with the upcoming sessions.
Faculty and students, you guys can have your refreshments and be back within 15 minutes.
Request everyone to sit down and start the program in 2 minutes.
That project will be very big.
Gentlemen, it gives me immense pleasure to welcome you all to the technical session 5 of the International Conference on Green Economy, SDGs and AI for Green Tech. This session will bring together experts who will discuss innovative technologies, sustainable materials, and career opportunities in the green economy framework.
We are honored to welcome Dr. S. Suryanarayan, Associate Dean of Research and Innovation at Godavari Global University. He earned his PhD in Physical Organic Chemistry from NIT Warangal and brings with him over 10 years of research experience with more than 50 publications to his credit. He has guided numerous PhD and MPhil scholars for his remarkable contributions to the education and community service. He has been honored with 5 national awards and 1 international recognition. A warm welcome to you. Now I kindly request him to please introduce our first distinguished speaker.
So good morning all. I welcome you all back to our important session. So well, above all 4 sessions, they are very excellent. Student above on the real time research works. And I didn't have all speakers in our 4th session who really related the research aspects, innovative practices, apart from the needs of our students who does know regarding the opportunities we are having from Taiwan. So coming for this 5th session, it is more or less almost connected to one of the very important SDGs, climate change. It includes the pollution control methods, the development of sustainable biodegradable composites, and intersection of sustainability of course, air and green technology, and so on. So we have 4 speakers in this session. And the first, it's my opportunity to invite Dr. Godavari. She is an accomplished economician from Delhi. She is from the Department of Mechanical Engineering. She has a strong research background in mechanical sciences. She has made wonderful contributions to advanced engineering systems and interdisciplinary innovations. Her work focuses on theoretical research and real-world applications. Fostering advancements in technology and sustainable engineering solutions also got her credit. Dr. Gray's dedication to teaching and research continues to inspire young engineers and strengthen India's academic scientific community. So, with a big applause, let us welcome very great Dr. Grant, please. Welcome, madam. She is going to give us a talk on health control law and pollution control.
Hello everyone. Okay, so this is my first time visit here in this place and also obviously in this university. And I like the gesture of the people, the hospitality, it's very good. So today what I picked up as my topic here is something which is part of this SDG. So we already know that we have these different sustainable development goals. And this part where we are talking about air pollution mitigation, this is targeting the SDG number 3, which is visible right here. It is like good health. Okay, so how can we work on the good health which the air pollution may cause? Okay, so here I should give some background of this because as I came here, everywhere I go, through the plane, I just look into the pollution. There are AQI measurement, air quality index. So here it is really, really very good. So I could show this value which I just took from the internet today morning. So it's 47. You see, AQI is 47 here. It's very good. It's green. The color also indicates it's very good here. So this topic came up as I'm from Delhi, and I did Delhi. As a resident from Delhi, so we are facing a lot of issues about AQI. So now it is in the range of moderate. So even when I'm talking about these values, 47 or good, then the moderate, if you look below, I don't know how much is visible. So this part, the numbers indicate how good the air quality is. If it is between 50 to 100, we say it is moderate. If it is 100 to 200, you call it poor. 200 to 300, unhealthy. 300 to 400 is severe. And 400 to 500 is hazardous. So you see 500, for 400 itself is hazardous. But in Delhi, during summer, or during winter, not during summer, during winter, December, we have values ranging to 700 or 800. You imagine, we stay in the gas chamber there. So it is a topic which actually came to my mind when I joined IIT. And I thought something needs to be done regarding this. Many scientists are working on this. So I started working with them to see if something can be done in this regard. But as a resident from here, Rajahmundry do not face this. It's really very good quality and quality here. Now, if I see the entire India map, that what is air quality? So nowadays, since it's raining in most of the places, it's within this moderate to poor. So in Delhi also now, it is in the less than 200. Okay, so as I'm saying, since it's raining, so you can understand we're talking about raindrop. So that's what came to our mind again. So this work which I will show is a DST project which we did, collaborating with 2 more faculties. So what we thought is, whenever it rains, we see that the air becomes fresh, the air quality index reduces. So how does that help actually? So before going to that, how this raindrop is helping, or how the water drop, maybe it can be rain, it could be from a spray of water, how that is helping. Let's first try to understand a little bit about which pollutant we are talking about. So again, if I go to this value 47, this value, how do they get? If you see below, there are two values, PM10 and PM2.5. So those indicates again the size of the particles. So there are very small particles of the size 10 micrometer or less, and less than 2.5 micrometer or less. So this entire chart, a lot of information is here, but the main thing to take home is the red arrows and the green arrows. And explosive one which I have shown here, the type of particles and the size. From right to left, the size is increasing, that is in micrometer. So if you see the size which is small, those are mainly from combustion. If you burn some kind of diesel, burn fuel, so we get very small particles of the range which I said, 2.5, PM 2.5 kind of thing. But if you are higher, those are mainly the dust or the thing which we get from construction activities. So those come from there. How does it impact us? So some of them we inhale it to the lungs and we have cancer. So that's how we see that these are the particles which are impacting our health. And why I mentioned the red and the green color? Red are the colors which are produced by human beings, which are made by man itself. So that's the thing. We are creating a lot of this and we are harming ourselves. So just getting some idea, maybe all of you know it, some of you do not know. So just have an idea about the size. If you think of your hair, the size of your hair is the radius of your or diameter is shown here. Diameter of your hair is again 50 to 70 micrometer, and the diameter of the spider silk is about 4 micrometer. So when we're talking about 10 micrometer or 2.5, you can imagine how more here particles we're talking about. And that's the reason it can go inside your lungs, because it is too small. So as I said, it can cause asthma, it can cause cancer, and there are different ways the particles come inside us. So what are the current technology which exists? So currently, we have this water spray or weight dust scrubber, or as a tool for removing dust. So in Delhi, most of the time we see during this winter, they spray water everywhere just to make the dust fall down. So what do the droplets do? Droplets interact with the particle gets inside the droplets and it falls due to gravity. So that's normal, a very easy way to do that. Then we have the HEPA filter. So we buy this indoor pollution mitigation, the HEPA filter, vacuum cleaner, which has the HEPA filter in it. So there the things get stuck and we get clean air. But the disadvantage is there will be a pressure drop, you have to change the filter, it is quite costly. We have something called cyclone separator or cyclone collector. This is again some kind of mechanical way of collecting more bigger particles. We have electrostatic precipitator. These are mainly used in industry. So they have some charged plate. They charge the particle as it is going through it, and the particles get attached to the electrode. We have the aeration technology where we have bubble, where air is going through a chamber full of water, and the bubbles of that air get rid of the particles and we get clean air. Sedimentation again for bigger particles, and this, which is something which is going on here, have very less pollution here, is what is the urban tree, or we got phytoremediation. So this is the plant. Plant helps in the remedy. Plant helps in cleaning these particles because the leaves in the plant or the different barks in the plant have surfaces which can take in or which can attract the particles towards it. So in many places where there are a lot of trees, we see very less pollution. But in bigger cities, that's a disadvantage. So when we're talking about electrospray today, so what is the electrospray when I say there is spray again, but which existing technology says that those spray are like series of spray as you could see, and the gas is going from the left towards the top, and it is scaling as it is going up. There are some patented technology which are there, but what we worked in our lab is on charged spray. We thought, can we charge the spray? And what that came to our mind is again looking to the raindrop. So we had some literature that the raindrops may have some charge in it. So if it has a charge, can that also help in attracting or absorbing more particles or more smaller particles in that way? So in how the particles get towards the droplet there are a few mechanisms. I will quickly go through them. So if the particles are very small, which are say the nanometer size, they have Brownian diffusion. So they move randomly. We cannot control the motion. So that randomly they move and go towards the droplet. We have inertial induction, which could be for a little bigger droplet, bigger particles. They will go and attach to the droplet. They are little heavier particles. We have interception again for bigger particles. What we are targeting is electroscavenging, where we induce some kind of charge to the particle. It opposite charge to the particle, and in that way it gets attracted to the droplet. And the last one is where we talk about something where we have temperature also coming into picture. So that we are not talking about. So we are talking about the electroscavenging, where the charge helps in more attracting the particles towards it. So we had a setup in the lab where we did experiment both for a single charge droplet and this experiment for spray. So I will quickly go through the results. I will not get more details into it. So the particles which we used to do the experiments were two types. One which was highly conductive. Even when we give the charge, it will quickly go towards the droplet. And another property which we changed is hydrophobicity. So hydrophobicity is a term which means whether the particle will get inside the droplet or it should go and attach outside. Hydrophobic means fear of water. Okay, so we use those characteristics. So here you see the value. So glass beads are particles which are good wettability. So they love water. So when they go towards the drop, it gets inside the droplet. And we have used carbon black, which is poor in conductor, poor in wettability, so it will stay outside. But if you look into the conductivity, the sigma P, we see the conductivity of carbon black is very good. So just I will show how it looks like. We have placed the particle, we have the charged droplet. The droplet is around 1.5 millimeter, and the particles are around 30 micrometers, so very, very small particle. And this go and attach to the water, it went inside the droplet. But when we have carbon black, which is hydrophobic, we see that it attaches outside the droplet, it doesn't go inside. Okay, so that's what we try to do in different particles. We try to understand the pollutant which we have in the air, how will the spray will help? Will it attach? It will, sometimes it ripples back, and sometimes it goes inside. And we want something which goes inside or attaches so that it is collected. So I will just go through one more slide here regarding single droplet. So here you need to see there could be, I don't know again it's clear or not, as I said, it could go and attach, it could go inside, it could rebound as well. So again, few fundamental study we did. At what case the particle rebounds? We do not want them to rebound, we want more to capture. So that was really some fundamental study. And based on that, we came up with something which says that if we have the force, which is electrophoretic kind of force or Coulombic force, that is the most dominant in this case. And that actually helps in charging the particle and bringing it towards the droplet. And the other forces, the drag, the inertial force, and there is a term called DEP, which is dielectrophoretic force. Those values are quite less. So this study was to understand what actually charges the particle and what actually brings the particle towards the droplet. And our target was to get some device. So this is the next experiment which we did with spray. We had instruments like atomizer and instruments like SDGs, which gets the value of the PM values. So with that, we came up with a very interesting result here. So the first graph shows we have two different kinds of particles, DHS and paraffin oil. And this is without spray. So this is just the concentration we see when there is no water spray. So without water spray, that is the mass of the aerosol. The black for the DHS, the red for the paraffin oil. Now we put the spray, which is uncharged, which is made by C naught. C naught is spray without charge. So that if you see there is a red color. So for DHS, once we just spray water, uncharged water, the amount of aerosol decreased. So if you see the black and the red, you can see the reduction. Then take the charge with the spray. C1 to C9 indicates the charge. The voltage is 1 kilovolt, 2 kilovolt, 9 kilovolt as well. So we are increasing the charge and we are seeing gradually the amount of aerosol capture is more and more. So that's a very good sign for us. You can see that by charging the spray, we can capture more particles. Similarly for the other particle of which is paraffin oil. One thing you should keep in mind that we cannot keep on increasing infinitely the charge. Because after some time, after 9 kilovolt, there should be some sparking and we cannot use that energy. So what we see that from 7 kilovolt to 9 kilovolt, if you see the symbols, irrespective of the diameter, we have mostly around 99% capture efficiency. So that is a very good point for us. And we have also checked with different concentrations, starting from a different concentration. Again, if we see that at a value from 4 kilovolt to 9 kilovolt, we can have any of that voltage and we can capture about 99, close to 95. We can capture about 95% of particles. So that's the entire thing which I wanted to show you, which we tried to develop looking into the rainfall. We thought of if the raindrop does that, can we replicate that in our lab? And now in the process of patenting it, we are trying to make it. Obviously, we cannot do it for outside because outside is a very huge space, we cannot capture everything. But we're targeting that if we could do it for indoor cases, where you could use the technology for capturing particles, where you could vary the voltage in this range, and we can capture the harmful chemicals. Okay, so with this, I will end. So this is again a conclusion. If you have any question, I will be happy to answer. Thank you.
Thank you very much, ma'am, for your insightful and innovative presentation on tackling air pollution using electrospray technology. Now may I invite Dr. N. Leelavati, Dean Academic Affairs, GGU, to kindly felicitate our esteemed guest, Dr. Badi Ray, as a token of appreciation and honor.
As Secretary Chairperson Dr. R.S. Suryanarayanan to kindly introduce the second eminent speaker of the session.
Thank you, Madam Director. It's a wonderful presentation. I think you must have marked on this. It's very important for in particular my 21st are looking inside laws, are this particular regulations, unless they are conditions, definitely we take part of laws. It really works well. So, very fortunate that you must have known. She didn't need a presentation. She has come with very good ideas, very good inputs to all of us. She has come with the equality index in Delhi, because Delhi is one of the cities in India. Everybody is clear about regarding the kind of the pollution and all. And also with Rajahmundry. She has given us a very good impression and important point that right now, at the beginning itself at 9:40 a.m. today, the air quality in Rajahmundry is very good. So thanks for that information. And it is a responsibility that today's air quality should not be get this. Because now there is a great statement outside. There is no time. And let's not have any kind of inspection. Let us start action. Because climate is changing. And have very important information. This kind of experiments and the mechanism involved in this particular electronic technology is very useful. Thank you so much, madam, for your excellent presentation. Now, I take this opportunity to welcome our second speaker of the session, Professor Godavari. He is a distinguished academician and currently now working as a professor in IIT Godavari. And he has an excellent career dedicated to the polymer science and sustainable materials. He has significantly contributed to the development of biodegradable plastics. But nobody will live the utilization of plastics. He is very much concentrated on biodegradable plastics, nanotechnology, and green engineering solutions. And engineering research is instrumental in addressing global challenges in sustainability and environmental protection. Professor Katya's expertise and leading continue to shape innovations in chemical engineering and inspire the next generation of researchers. He is about to give us the talk on sustainable plastic formation for conducting for commodity engineering and biomedical applications. Welcome you, sir, please. Professor Vimal. Thank you.
Thank you, sir. So, thank you very much for a nice introduction. And first of all, I thanks to the GDU for inviting me here for such a wonderful meeting. And I'm really fond of to join a Indo-Taiwan meeting. I think in 2021 we have organized first time that was a Indo-Taiwan meeting, and fortunately it was a kind of Godavari. And there are many occasions we met. I am very frequently visitor traveler to the Taiwan, and most of the cities I have visited in Taiwan, different universities. As my fellow speaker have already made, it's a wonderful place. I think it's a dream for the student to visit Taiwan and explore the best technology, the modern technologies, the way the country has been established and developed. So that will be really very good experience for the student who will be visiting Taiwan. Number one, and number two, the fact that you can see the modern technologies what they are using and that can be brought into the country as well. A lot of similarities. Taiwan has a big coastal area. India also having a big coastal area. So many problems and are common. Anyway, without wasting much time, I would like to talk about a few things what I am doing. So today lecture I will talk about sustainable polymer for my experience on community biomedical and engineering application. I am from IIT Godavari. It's as good as Rajahmundry city, so kindly visit to the IIT Godavari as well and visit to IIT Godavari. Very beautiful campus. So what I am going to talk about, I am going to talk about the plastic. Very good material, wonderful material. We use from day to day life. There are certain issues associated with this class of material where I would like to bring you notice. So if I was really going to see the material in two perspectives, one is the beginning of life option and another is the end of life option. The beginning of life option suggests from where the material comes, whether it is coming from a fossil feedstock or the renewable feedstock.
and then what is the fate if it is coming one after another. So you might be seeing in the slide, when I talk about the beginning of life option, it means if a plastics, at least 30% of the carbon comes from the renewable feedstock, we could able to tell such kind of plastic is a bioplastic or bio-based plastic. It is having an inherent benefit because we could able to have a shorter carbon cycle. So that is the advantage if I am going to make chemical from the renewable feedstock. Plastic in my top, so the bioplastic is it may help to achieve the shorter sustainable carbon cycle. However, the other part of the cycle you can see that end of life option that is quite alarming and challenging. Okay, so you can see this part of end of life option. That is what our concern is. That after the service life of such a beautiful material plastic, what is the fate? So, if you really would like to bring those class of material after the service life, if it decomposes or if it goes back to the nature, that will be really going to help. Because in that way, we could able to remove the carbon from the environmental compartment, and that's where we could able to help with the carbon footprint. So, you can see that what exactly I wanted to talk about. I wanted to talk about whether I need a red carbon or green carbon. Green carbon, you can see, have a shorter carbon cycle. Red carbon has a very largest carbon cycle. That way, it is more advisable that if you can use a biomass, agri or non-agri feedstock for making certain class of chemical, it's good. Okay, so I have already spoken. Basically, what happens is really going to talk about the plastic material. Most of the plastic materials goes for a commodity application, and packaging is one of the areas where the concerns are associated with it. Around 40% of the plastic what we manufacture goes to the packaging application. Out of the 40%, 50% used to go for packaging application. And where the problem arises, because you can see in the street or nearby, you can have a litter of these kind of packages because of the higher surface area to volume and weight ratio. So that is, and you can see what is so far more than 90% of the plastics have been used for has come from the fossil feedstock. So there, I will say that not only us, the world is trying to make this kind of plastic from a biofeedstock, as well as after a service life, if it can go back to the nature, that will be good. So you can see why plastic is important for food packaging application. You might have seen that it's a lightweight, flexible material, and that can protect from the contaminants as well as the damage of the food. And it can be easily handled, and the only problem is the difficult as when we talk about end of life options. So the food packaging is important, and being a part of certain regulatory committees, and we really looking forward a very good material which can replace a conventional food packaging. So if you can see, these days we were advocating the conventional plastic. How we can replace how we can optimize the conventional plastic. So, especially for a food packaging application, we can do the mechanical recycling. There is no chemical transformation is there, and other is a chemical recycling. So, I would like to tell that India has taken we have taken our initiative that to recycle a plastic first time. Being a part of the FSSI on this particular panel, I would like to say we have opened the carpet, the PET, the PET bottles can be recycled and again come back to the food supply chain. And we have opened the chemical recycling for PET, polyethylene, polypropylene. We could able to recycle it now, and we can bring it into the supply chain. So it will give a benefit to reduce the dependency on the fossil feedstock. So somewhere the circularity will be going to help. So that means attempt at the regulatory framework we have already made in order to optimize the end of life option
However, you can see there are leakages. Even though you would like to recycle, it is a blessing in disguise in a country like India that we could recycle as much as plastic compared to the other part of the world. Okay, but still there is a huge leakage, and leakage is going to have. This morning we have a blue ocean presentation. You might have seen there is a lot of littering going into the ocean and as well as in the field. And you know these days we are really in the world like microplastic. That is again a big challenge. The fact that even a structural material can easily be removed, but once it is going to be in this particular length scale, the particles on that length scale, it is going to be very difficult. So you might have seen certain articles where these particles, microplastics, are coming into the food. So that is really alarming for all of us. That how do we remediate the microplastic, which is really very challenging, whether it is in the soil or it is going to be in water bodies. So anyway, those are the things associated to the conventional plastic. I don't know. Yeah. So basically, I work or we are trying to make it a biodegradable plastic or a compostable plastic. If I would like to classify the plastics can come from biomass straightforward, whether it is a saccharides, it's going to be the lipids, it's going to be a kind of a cellulose. These are the biopolymers we can directly use for making a sustainable or eco-friendly plastic. However, there are ways by which the enzyme and microorganism can lead to the plastic. One of the examples like polyhydroxyalkylate. There are synthetic plastic. We call it the polylactic acid is a synthetic plastic. But the feedstock of this plastic used to come from the renewable feedstock like lactic acid or sugar or starch base. So that's why this kind of a plastic is considered to be a bio-derived plastic. However, it doesn't mean that when we talk about the biodegradable plastic, it will always come from the renewable feedstock. There are examples available that petrochemical feedstock also need to be a compostable plastic. Like these days, you might have carry bags, sometimes compostable carry bags like PVAC that has to come from the petrochemical feedstock. So there are the two terms like we have to optimize the beginning of life option. I mean to say the feedstock as well as the end of life option. So there are I mean to say there are polymers which are compostable in nature. So I work on very many chemicals, plastic, and most of you might be heard about this polylactic acid. It is a very good chemical and it is considered to be a compostable polymer based on IS 17088, ISO 17088, and ASTM D6400. Under that framework, it is considered to be compostable polymer. Even though the Western world, like NatureWorks and some of the companies in Thailand and in China, they are manufacturing this kind of polymer. But still, this class of plastic is having a problem as far as application are concerned. You can see here that even though if I am going to drink a coffee with making the cup or the glass of it, you can see it will deform it here. If I am going to make the bottle out of this particular polymer, it is not going to be good to replace a PET bottle because the oxygen transmission rate is very high, more than 10 times than PET. So we cannot replace the PET. We have done certain interventions in our laboratory in order to replace, I would say, make it a product out of, I would say, using, I would say, a product which can solve this problem. And another problem is how we can use this class of a polylactic acid for a high service applications like interior of automobile, so that after a service life we can able to destroy. So we have done many attempts in order to solve these problems, come up with the different formulations, and moving forward, we have multiple such kinds of intellectual properties, especially for development of this class of plastic. We have come up with an up to 200 kg production facility at Godavari for making these kind of class of biodegradable plastics and going to a 1 ton production plant at Godavari for making this. So all of the interventions we have made in order to have establish the production of this kind of a bioplastic. So this is kind of our own process flow diagram, and then we have done the detailed engineering and come up with this plant. I would like to tell you what I was talking about. If I want to replace the PLA, PET with the PLA, we have to reduce the oxygen transmission rate by tenfold. Quickly, I am moving that I have made so many attempts bringing a nano molecules into it and try to, whether it is mechanical compounding process or through using the nano clay as a reactor and to form a nano composites of very low length scale. I mean to say, we have done all these things. I would like to tell you, when we are trying to improve the properties of dispersion of this material in PLA, we could only reduce the oxygen transmission rate, not 60%, that was not ideally. Later on, we realized if I will take biopolymer like hydrogen, if we make the nanohydrogen, disperse the nanohydrogen, connect the nanohydrogen with the PLA master batch, and then if I am going to polymerize, compound it, we could able to make it a PLA film. I need to say now the modified PLA, you can see normal PLA is the oxygen transmission rate this much. However, when we are making this intervention, bringing a nanohydrogen into it, we could able to reduce oxygen transmission rate significantly, which is equivalent to PET oxygen OTR, as well as we reduce the water vapor transmission rate. So that way, with this kind of interventions, we can have a new formulation, and that will really going to help to replace the PET. Also, big problem of this class of a material, like flexibility, we could able to reduce the glass section temperature. Okay. Similarly, what happened? We have made an attempt using a lactic acid oligomer and put it a guar in it. We can able to make it adhesive. This is the bioadhesive. Here I would like to tell you, bioadhesive for example, ceramics and concrete, you can see, if it can be visible, I don't know. You can have on the substrate, when we do the lab shear test, we will find the substrate failure rather than adhesion failure. So such a good adhesive it is, which is come from a bio-based material, and that is considered. Anyway, slide has come in between. This was just an accident by doing our experiment, and we got this class of material. Okay. So what happened when we have developed this bioplastic, the PLA, we are working on a PLA, PVAP, PBSA based on the packaging. You can see that we have a semi-industrial plant, and I don't know if you can see here. Okay. So this is I will show you further. We could able to make it a compostable film. The bags also. That is what I'm showing it here. You can see the student can see that how we can make the whole film through this particular, I think, example. Okay. I'm just leaving. So these kind of bag, what happened? We have given to the railway. Now the 15th of August, all the North Frontier railways now going to use the plastic which has been developed by us, and that more than 25 trains, around 40,000 bags for the petrol, for any air condition. So that has been already. So you can see that we have taken our product, we have printed, we have cut, and then finally it has gone to the to there. So many interventions in the railway now we have taken, we are working together. So our target is that to replace some non-degradable plastic with a degradable one as far as possible in the Indian railways. Okay, so this small video, I don't know, volume is not there, but that's what we have done in the whole North Frontier Railways. So we have a very well equipped facility that I think robotics, especially on biodegradable plastics. We have a small research facility as well as a translational facility. I will show you that we are other intervention we are working for a biodegradable plastic. These are our compostable facilities. Anyway, so I'm just skipping. So this kind of bags for the railways, so it has been executed, and then all wet rolls they have filled into that particular bag. So anyway, now another case, these class of material we have utilized for mushroom cultivation. So normally, if you see the mushroom cultivation, we use a polypropylene bag. When we have used our formulated bag, we found the maturity of the mushroom has reduced from 22 to 23 days to 16 days. Okay, so we could able to get the same product in a lesser time. And after the service life, full protein biomass based package can be thrown into the farm that increase the fertility of the soil as well. That has been tested. So utilizing this kind of a bag for a mushroom cultivation as well as for the mulch film, that also we are testing. It is not only limited to this class of polymer to be used for a commodity application. We are trying to make it the material for engineering application. Like most of the polymer solar cells are going to be cast onto the PET substrate. We are trying now to replace a PET substrate with a PLA substrate to make it a compostable, low-cost polymer solar cells. So we have made an attempt. Maybe all whatever I am showing, it is all published, it is all documented, it is there. If someone needs, they can follow those papers. So we have come up with a stereo-complex polylactic acid. Work has been done since long, but we have come up with an industry viable technology through extrusion resin. And I would like to tell you, when we have used our additive, you can see we could only have a stereo complexation, not the homo stereo crystals, which is commonly presented. So we have developed, you can see, normally this class of a material is having a heat deflection temperature 70 degrees centigrade. We have shifted this 70 degrees centigrade to 140 degrees centigrade. It means now we can make the product out of this class of material, and that will be useful for a high temperature application. I would like to show you an example. I don't know. So this is the plastic. This is the conventional biodegradable plastic. I'm sorry. So this is a conventional biodegradable plastic, and that's what I wanted to tell you. If you pour hot water, that is the way it deforms. It deforms. Then we have modified, taking this complex polymer, and then we have made it a thermoform grade. And you can see that it's a pipe that thermomechanically stable. It means it is stable up to 140, 150 degrees centigrade. So the material can be used for very many applications. And such material we have utilized for the biomedical application, in making it a different kind of the fixation devices and the implant. So we work, and depending on our environment, we have developed these kind of fixation devices. You can see. Okay, I don't know where I is. Anyway, so you can see that we could able to make it different particle screw, cancerous screws, staple blades, pipe. All these things we can make it. I would like to tell you that if you go to the market and get a durable screw, it costs from 10,000 to 15,000 rupees, and our product is even less than 500 rupees. We have established starting from a monomer level to the final finished product. And that is what we have developed. And with this is having a heat crystallization temperature up to more than 120 degrees centigrade. So it is good for our biomedical applications. Now we are working in clinical trial to bring this product to the market as a resorbable fixture devices. We work on edible packaging, the biopolymer based edible packaging, in order to improve the post-harvest, reduce the post-harvest losses in our country and increasing the livelihood for the farmers. So we have made significant formulations in order to increase the shelf life of the vegetables and fruits. I would like to show that, like if you talk about the orange grapes, and these days I am working on a rambutan. I think it's a fruit which is more popular in the Kerala. So that we are trying to increase the shelf life. The shelf life is very poor in that particular kind of fruits. So we are trying to work to develop a formulation to increase the shelf life for that product. And you can see, like tomato and potato is very important for all of us. We could able to increase the shelf life more than 2 months. And especially similarly for us, orange is important because in the northeast we used to get a Kasi membrane. So we are trying to make a different formulation in order to increase the shelf life of vegetables and fruits. So you can see our tomato, even if we pour from the biopolymer, more than 30 days we could able to keep the potato in a normal conditions. And these are the biopolymers, the polymer what we used to consume in day-to-day life. The formulation has been made with it, it is non-toxic in nature. Similarly, I will say for pineapple, we did I mean so many. This is one perfection. Another thing I would like to tell you, in order to make this kind of bioplastic, we need a sustained supply of the raw material. That's why in India, we have, I mean to say in the northeast, bamboo is the green gold for us. We are converting bamboo into the intermediate product. One of the company, Novarika Refinery, they are making a bioethanol, and there is a co-product for furfural. We are converting this furfural for making a adipic acid, succinic acid, caprolactone, lactic acid, all these kind of feedstock, which is going to be a monomer for development of different kind of bioplastics. So it's quite a big initiative as a CO sustainable material for development of monomer. That is what we are working on this. And so this is basically a bamboo project where we are utilizing a bamboo using the possible interventions, cellulose, lignin from a bamboo, converting in different chemicals, and then trying to make it into circular model. So we will be going to get the succinic acid, caprolactone, that will be utilized as the monomer for making biodegradable plastic. That's what I should do. So I will say we are trying to convert a biopolymer into the nanomaterials, whether it is cellulose nanofibers, cellulose nanocrystals, nanodiscs, nanochitosans, and these nanomaterials are really going to enhance converting and changing the waste into the value-added product. A lot of innovations we are doing into this. We have to Indo-Taiwan project, the first Indo-Taiwan project what we have done. The number one we were working with the establishment of a microbial fuel cell and utilizing, because it is going to be the intervention with the water. We could able to make whether the electrodes will be a flexible electrode, comes from the renewable polymer base. And recently in the second Indo-Taiwan project, we are working for the generation of a biohydrogen, and whatever is left out, how can you convert this left out into the biomonomer for production of a polylactic acid? That's what we are doing it. The very good innovation, I would like to tell you, it is very close to me. We are trying to establish an ecosystem in Assam that is a toy manufacturing, biodegradable toy manufacturing in Assam. We have taken 4 villages in Assam, around 150 women. We are trying to make them as micro enterprises so that they could be able to make the toys which are sustainable in nature, that can be later on bring it to the national level and to increase the value addition, I would say, livelihood to our people who are living in the rural area using an industry 4.0. This is the project given by the Department of Science and Technology, Biodegradable Vice Center, Madam from BCPC Secretary, she is there, inaugurated that all. So we have established more than 100 3D printers, all different kind of, and we are training these women for developing those products as well as doing all possible interventions so that we will have a customized product. Recently, they got around 50,000 statue ordered from some of the company. So that's what this is another intervention, and that is really close to us. It's really good to give a livelihood to the. Another thing is that you might have seen the non-woven bags we are going to use, the tapian bags. We used to use for a cement industry for many applications. We have converted the polypropylene tapian bag to the compostable tapian bag. We have developed the technology where we could able to make it a tapian bag fabric and bags, and that can be. This is a fully compostable bag. Okay, it can sustain more than 90 degrees centigrade without deformation. Can be used for a packaging application and many other applications. So that's what we are developing. We have our own composting facility where we test the formulation what we have developed, whether it is really going to be a compostable and what is the release rate, what is the degradation profile or composting profile and everything. We do it our place. I request you, we have developed. Because most of the plastic I have given you the name that it is degradable, compostable under the standard, and standard says it's a 2 minute only. Okay, the standard says that at 58 degrees centigrade, but we are trying to develop a compostable plastic which can degrade compost in a room condition. That's the goal. Okay, so various product, various accolade to our students. And finally, I would like to thank you. Visit our place, and if you wish, you would like to collaborate with us. Thank you.
Thank you very much, Professor Vinod, for your thought-provoking presentation on sustainable plastic and their wide range of applications. May I now invite our session chairperson, Dr. S. Suryanarayan sir, to kindly state our esteemed guest, Professor Vimal Katia, as a token of appreciation and honor.
Moving ahead, I request the respected chairperson, Dr. S. Suryanarayan to kindly introduce the third eminent speaker of this session.
So thank you, sir, Professor Vimal. And we really enjoyed this presentation. Actually, he did not give a presentation, he has given us a virtual biodegradable plastic industry in working condition. He has given lots of things here. By the students, you need to remember, everyone was wearing lots of packaging materials, food materials. How does in fact the food is going to be disturbed? Where as soon as we are having these packaging materials. He covered an excellent information on one of the very important things. What PLA is being used and it's also being used PLA, modern PLA. Very important aspect is biodegradable toys. It's also very important point to recognize excellent things as covered here. Why in fact whatever food is being disturbed as we are using the plastics and it's a point of view and most of the things if I am not wrong and the plastic has been introduced almost in 1957 because we found that it has a lot of applications. And in 1907 actually the what's called bio Becquerel has a 100% synthesis plastic. We are using it for a lot of applications. Now we are getting a lot of problems. Now, one of the very important thing to recognize is microplastics. So, here already given show like 90% is giving this kind of biodegradable plastics. So, thank you sir for your wonderful presentation. Give me a recap class, please. Now I take this opportunity to welcome our next speaker, Dr. R. Sima. Dr. Sima is an accomplished academician and currently serving as an associate professor at Rajahmundry Institute of Science and Technology in Chennai. He has a dedicated career in teaching and research. He has contributed significantly to advancing knowledge in the field of expertise. His work emphasizes innovation, industry applications, and nurturing young talent in science and technology. Dr. Sima's academic and research pursuits continues to strengthen the institution's commitment to excellence and social development. He is about to give us a presentation on sustainable solution in medical science, the green processing of natural fiber composites. Welcome, Lisa.
Okay, good afternoon, everyone, and thanks for the opportunity to make a presentation over here at GD. And my topic is green composites and sustainable development, preparation of green composites and sustainable development. And I am coming from Satyagraha University. We have two excellent research centers, one is phenomenal Dr. JPX and another is Industrial Research Center. So where we conduct this experiments. And I would like to take in a basic manner. So in the first, we need to know what it means by composites. So generally, composites made up of two different materials having different properties to attain a favorable characteristics of without compromising the individual products capacity. And naturally, you can take the boards. Okay, this is the composite material. Where in the composites, the main parts is matrix material, and in that we are having polymer, metal, and ceramic matrix. So into that we reinforce the materials in the form of particles, pipe, plates, pullers, and etc. And it is used in many areas like construction, automobiles, etc. And this shows you how the composites are made. So usually they take the fiber reinforcement, which is highly stable and which is having high stiffness and low density, where it will be mixed up with the matrix, which is having good clear properties. And then if you combine all this thing, we will be getting the composites which is having good shear properties with the high strength. And if you take up the type of reinforcement fibers, generally it is classified into two major categories. One is natural and synthetic. So usually in medical industry they are going for the synthetic reinforcements, where it is classified as two things. One is organic and inorganic. So in the organic we are having Kevlar that is used in the defense systems, and in the inorganic we are having this plastic carbon. This is the major use that they are using in the composites. And when it comes to this natural fibers, we are having three classification: animal, cellulose, and minerals. In that, I have concentrated more on the cellulose as a plant fibers. Okay? So, as the topic related to the green composite, green composite, so we are going to discuss much about this plant fibers. Okay, so this is extracted from the different parts of the plants, the plant, seed, leaf, fruit, etc. And what are the advantages of the plant fibers it used for the composites? So, first one is the renewability, and next one is it will reduce the carbon footprints in terms of manufacturing process, and it consumes only low energy consumption and reduce waste. And the main thing was the biodegradability, which has been discussed in the previous presentation. And these are the different type of natural fibers which is available. So generally these nowadays they are calling it as commercial fibers. But nowadays, researchers have been moved to discover the new fibers. Okay, so due to the scarcity of the submersible fibers, I will include those fibers over here. If you take out this one, sister Scotland, Kaiching, Africa, and on. So these are the fibers which we have discovered for the use of the steel composites. And if you see this, I have given the tensile strength. Though the tensile the E-class fibers we can take, so it's next strength of 2000 to 3500 megapascal. So it is not competing with any other natural fiber. That's why we call this green manufacturing others natural fiber composites could be used for the lightweight applications, not for the heavier applications as the synthetic fibers which are doing it. And the type of reinforcements, as I said, we have to reinforce the fibers into the matrix. So different type of reinforcement they are following us. So first one is particle reinforcement, where we can do it in the large particles of dispersed system. So in case of the fibers, we can do this one with the continuous and discontinuous fibers. So in the discontinuous, we can put it in the aligned manner or in the random manner with the matrix. If you go for the structural oriented one, for example, in the structural applications, so we can do the laminates and the sandwich by using this system. If you see on the left side, so you can see unidirectional mat fibers that can keep it or bidirectionals. So that generally they will be having this 0 dB and 90 dB orientations. Whereas in the first two, you can see the short fibers and long fibers. So commercial fibers mostly if you're using this helium or cellulosic, they are using the long fibers. That you can make in the form of mat to do the unidirectional or bidirectional. And sometimes they will be using in a randomly oriented distribution also. Whereas researchers discover new fibers from the mostly if you take it from the bark of the plant. Okay, so you cannot expect the long fibers from that one. So in that case, they will go for this short fiber reinforced process. And in the fiber extraction process, we are having many types. So one is microbial degradation, another one is mechanical degradation process, and enzymatic. So in that we have followed the water treating process, so which requires minimum energy resources. So where the plant which I have shown over here is a cis products plant. This is stale. Okay, so that we have collected and we have done the microbial degradation and the extracted fiber, and this directly we can use it for the making the composites. But to improvise the properties, mechanical properties of the material, we used to do the chemical treatments. Generally, we will take the sodium hydroxide. That's the chemical treatment that we use it. So first we will weigh it and we will mix up with the by using a mechanical vibrator. We try it to use it as a reinforcement. When you compare this matrix material, so the matrix classification you can take it, thermosets and thermoplastics. I will look about this first. The thermosets is a one which we cannot reshape it or reuse it. Okay, once we use it, we have to throw it away. Where if you go for the thermoplastic, we can reuse it. Okay, but still, recent decades, not recent times, recent decades only they have gone for the. They are thinking about the recycling of this. And composite preparation business. These are the different methods which is developed. Okay, so mechanical method. So where we will be having the mold, we will place the fiber, we will pour the resins, and we will use the roller to make the composite. Whereas the injection molding, we fed up the fiber and the matrix into the copper, and it will inject the material to the composite mold. Okay, so in general, we used to go for the extrusion machine before this injection machine to improvise the properties of the composite. And next one is the compression molding, where it's similar like handling method, where we will use the pressure and the temperature in this compression molding. And the bottom one is the new one. It's not a new one, it's a recent thing like 3D printing. So we used to grind the natural fiber into the nanopowders by using the ball mill, and then we extrude it and we'll make the filaments to make the thread knitting products. And this is one method which we have followed to make composites. Where, as I told you, to make a green composite, we have to concentrate more on the biochemical matrix. So in that we have selected this polylactic acid, so it is a biochemical one. So into that we have introduced this natural fiber that is also biochemical. We have done with the two-roll mill, first initial one, and next one we have moved on to the commercial molding, and then we have made this mill. So the difference between the previous methods and this method is, if you take out the natural fiber, it is very important to find out the critical end of the fiber to utilize the maximum property of the fiber in the composite preparation. As you know, the reinforcement is having a high strength, so that will determine your strength of your composite. So if you go for the injection molding, due to the working aspects, okay, so you can fit only maximum of 3 mm of size of this fiber. But in the two-roll mill, you can go up to 5 up to 8 mm. But you cannot always that all the fibers which are feeding into the two-roll mill will retain its same length. But most of the fibers will be retained the same length. So when compared to the injection molded product, the process, this process will give you the more properties, the same properties than the injection molding process. And these are the advantages: high strength, low cost, lightweight, and more than next. So these are the major challenges while you're using the natural fibers. So one is moisture retention, variability in natural fiber properties, and compatibility with the polymers. If you take the moisture absorption, you see here the water absorption test which is coming over here. So the fibers will absorb the water, it will start to swell, and it will make a microcracks. Due to that, the matrix debonding will happen. So this is the first challenge which we gone through this natural fiber composite, preparation of natural fiber composites. And next one is variability in natural fiber composites, where depends upon the species. Okay, if you take a single plant, okay, different type of species are there. So different type of species gives you different properties. So next one is environmental factors, that is growing and soil composition, etc. And next one is processing treatment. How are you extracting the fiber? As I told you, water process better than the mechanical process. So these are all the things that determines the natural fiber properties. The next one is compatibility with polymers. As in the previous presentation, they told very clearly about hydrophobicity and hydrophilicity. The hydrophobic characters mostly will be having by the matrix material, where if you take out the natural fiber, it is hydrophilic. So general problems like the compatibility with this natural fiber and matrix is going to happen here. And next one is polarity. So where if you consider this matrix is non-polar, where natural fiber is polar. So due to this, the bonding between the fiber and matrix get this. And the same thing over here. To improve the compatibility. Okay, so the researchers have gone through the surface treatment as I shown in the previous slides. So image treatment. Okay, I showed that one. So that type of treatments are there, chemical, physical, biological. In that I told you the chemical treatment. So if you do the chemical treatment, the first thing to take out the alkaline treatment. So where here, if you make a fibers in a alkaline manner, okay, by removing the wax material, which is considered as if you take up the wax material, you will be having cellulosic and non-cellulosic components. Okay, so amorphous materials they used to call it as. So to remove this non-cellulosic materials, the chemical treatment is used. Okay, so moreover, it will align the fiber directions. So if you're having, they used to say this microfibril angle. So if you're having lesser angle, so it means like if the fibers are straightened, so you will have major problems. And silicon coupling agents where not only the treatment is done as like a silicon coupling agent, so making the coating over the fibers. And next one, acylation by removing this hydroxide groups into this acetate groups, and benzylation by using the benzene product. We can do the different type of treatments. And in the physical treatment, we are having plasma, UV, and ultrasound. I'm not going to discuss much about this. And biological, we are having the enzymes. Okay, so major thing is, if you take out the composites, there are two things that one is biocomposites and another one is biodegradable composites. Biocomposites is just to say that if you mix up the synthetic fibers with the matrix materials, for example, the biodegradable materials, not the thermoplastic, which I'm saying, but so they are called that one as biocomposites. Whereas biodegradable is nothing but you're using the natural fiber, that is also biodegradable. Whereas if you use the thermoplastic, that is also biodegradable. So in that case, we are calling this biodegradable processes. So here the cradle to grave things has been explained this. And this is the topic which I want to discuss where it's a green manufacturing, as I told very clearly. So green manufacturing is nothing but making the composites completely biodegradable. And the main aim was like minimization of illness, minimization of waste pollution, promote resource efficiency, embrace renewable energy, sustainable materials, recycling and reuse, and improve efficiency. So these are the major things that the green manufacturing is able to. And the main thing is they maybe how to reduce carbon footprints. So mainly if you use the synthetic material carbon fiber, the name itself you can understand you will be having a high carbon footprints. So if you go for the natural fibers, it will have less carbon footprints. And this is the graph which is shown for the greenhouse gas emissions in production of this fibers. If you take out the carbon fiber, it is having the maximum. Whereas if you come for the natural fiber, here you can see the bar chart has come down because in the production of the natural fibers, you know very well that the plants absorb the carbon dioxide, right, and release the oxygen. So in that case, it is compromising that carbon footprints. And in the natural fibers, this is about you come to know about LCS, the life cycle assessment. So for these things, we have to take the consideration of the transportation, fertilizers, feed operation, everything to make to grow the plants. So in that case, they have given the green gas emissions for the hemp, for flax, tube, telegraph, and flax and fibers. And what are the factors influencing this carbon footprints? So the fiber type, material manufacturing process, and chemical stations. So fiber type, as we already discussed, we have to go for natural fiber where it is having a good biodegradability. So in that case, it will automatically reduce the carbon footprint. In case of matrix materials, though we are talking about the thermoplastic, as the previous presentations has mentioned very clearly that we have to go for the bio-derived matrix materials, right? So apart from the PLD, most of the bio-derived resins we have to use it for making the green composite preparation. So these are the bio-based resins, so polylactic acid, and the classification already as shown in the previous presentation. And these are the different type of polymers which are in the tensile strength, tensile model strength, density, etc. And biodegradable property, but because polylactic acid has been derived from starch, wheat, or rice bran, and polylactic acid. So this to be used in the biomedical applications. So poly PCL, that is the covalent drug delivery. So PHAs is used in the various applications like packaging and biomedical applications. So these kind of matrix we have to use it for make the green manufacturing process. And next, so regarding the manufacturing process, I showed you many things like combustion body, injection body, all those things. So into that, we have to, it is essential to use the low energy processing techniques to reduce the carbon footprint percentages. So methods like that, I did give you the picture in that one. Yes, I have included in this one. So generally they replace the 5% of matter. For example, if you want to make them the random oriented, you can spread the fibers over there, or then you can feed the resin, and if you apply the back, so it will make the composites, okay, with the lesser energy. So where there is no need to apply the temperature gradient, so it will reduce the carbon footprint. And if you go for the other thing, that is the needle punching, okay, so now the techniques are very clearly. So in that case, you have to use the needle punching method, where you will be placing this fiber, the number of needles will be there, so that will make a punch on it, so that will make it as a matte plate structure, but with the randomly oriented. Okay, generally if you take out the mat, any mat, that will be oval. Okay, right? So instead of that one, we are going to make it as a non-oval. Definitely the properties, take the properties, the non-oval will be lesser than the oval material. That is absolutely right. But in this, when you take for the processing techniques, that means only the lower edge. And if you take out this one solution casting, so where they use the chemicals, that's the solvents, okay, to solute this fiber and the magnetic material, and they will allow it to solidification, so that it will make the composite. And next one is injection molding, compression molding, where the fiber and magnets kept over the mold, and over here the down is the injection molding. So these are the low energy process techniques. And now the next one is, so we are making the green manufacturing. So we have to consider the waste goals. So as the SDG goals. Okay. So in the waste division, they have mentioned us in the carbon fiber. So it is generated 74 tons in 2017, and it is expected to be 5 lakh tons in the year of 2015. It's given by the European standards. And the next one is world industrial waste generation, that is estimated as 1 lakh tons, and it is by 2015 is estimated as 680,000 tons. And considering the biopolymers, already they started to do this green manufacturing. So it is 2.4 million ton production. It's not about the waste, it's production. So 60% are using in this packaging applications. So by the end of 2030, they are able to recycle this plastic. Almost 30% of the plastics will be recycled. Okay. So the main problem is, if you go for the composites, as I mentioned, synthetic fibers with the magnets, right? So if you take out the main reactant base, the glass fiber is used over there. So glass fiber with the epoxy, glass fiber with the epoxy, they already started to recycle it. So after the end of life usage, whereas packing materials, to take out the packing materials, we normally used to dispose it, right? But when you consider about the end of life period, it is not completed. So, for example, if a product is having a lifetime of 10 days of time, so if we consume one time, so we will throw it out. So in that case, we are not worrying about the recycling of this biodegradable materials. So our aim is to recycle this biodegradable materials to utilize the full life cycle of the materials. And if you see this, where this is about the fiber biodegradable material. So fiber with polylactic acid, so that they have used with the H2O dissolution, and they have immersed it, and they have recovered the fiber, and once again they are just mixing it with the virgin fiber again, are completely with the recycled fiber. We use for it as downscaling and upscaling. So if you want to make the upscaling of the recycled thing, we can go for the addition of particles. Okay, so addition of nanoparticles. If you do that one, definitely we could go for the upscaling process. And these are the biodegradable composite applications. And these are the limitations and futures. The first one is, as we mentioned, we have to address the spike matrix bonding issues. And next one is moisture concerns. And next one is production scalability. Production scalability in the sense, we should have some collection point to collect the biodegradable materials because people used to throw in all the places, right? So instead of that, if you have a strong collection point, so it will be very easy for the recycling process. And next one is scientific challenges, where I mentioned that different type of species are there, different type of conditions, the growing condition of the plant fibers. That if we standardize that one, we can arrive at better properties. And in addition to that one, we have to go for more extraction techniques for this, and we have to integrate small technologies like AI. And next one is more policies that the government has to go for this green planet proposals. That's all about my presentation.
Thank you so much, sir. May I now request our session chairperson, Dr. S. Raju, to kindly felicitate our esteemed guest, Dr. Shiva, as the token of appreciation and honor. Thank you, Dr. Sivagaru. So we had a presentation regarding this green development. So excellently presented the importance of natural fibrous materials, different kinds of fibrous materials. How does we can develop composites? What are the different materials they are also using for development? We can also express different challenges they are facing. Most of the things, like you mentioned, the genetic implications, the environmental factors, and the process are also being some challenges where they are applying these particular fibrous materials. Let us see that how these scientists or how the research is going on in development of green technology. So friends, a small request to all of you, now we are all passing through the Ganapati Navaratri. We are using a lot of natural materials, leaves, plants, and all. Don't just throw them in Godavari or any other river. There are a lot of important medicinal elements, so many things. We can also check if they are being utilized as fibrous materials for development of composites. Thank you, sir. Dr. Siva. Please give them an applause for. Now we are almost very close to the ultimate session. For the last 2 days, we are having discussions, excellent presentations on SDGs, Sustainable Development Goals, artificial intelligence for development of green technologies, and so many aspects we are also having. Now, the intersection of all these things are very important. One of the goals like SDG 74 is nothing but the collaboration between the different SDGs. Now we are going to have an excellent comparison, like the how does in fact we can intersect the sustainability, AI, and green technologies. It is going to be an excellent session where in fact all the SDGs where we are covering off the last 2 days are going to happen. Now this is a time for us to invite Mr. Prakash Gupta. He is going to give us a talk on intersection of sustainability, AI, and green technologies. Welcome, sir. He is a visionary entrepreneur and currently serving as the founder and CEO of Standard and Private Limited, Bangalore, Karnataka. With a passion for innovation, technology, and solution, he has been instrumental in
steering the company towards impactful contributions in the field of geospatial intelligence, earth sciences, and sustainable development. This leadership reflects a commitment to harnessing technology for societal progress, fostering industry academia collaborations, and driving entrepreneurial growth in India's innovation ecosystem. Welcome, sir.
Yeah, waiting for lunch and the only person between you and lunch. So sorry for that. But what I'll be offering you is a lunch bag in which you can actually store all the very interesting technical talks, what you had, and carry it in. It's like a bag which you can wrap up everything what you've learned and think about how you take it forward, how you act. So I would rather start with this philosophical goal. It's a bring to a planet in the belief that somebody else will take it. Now, I'm not completely agree with this quote because it's not the planet that needs to be saved. It has reset itself 5 times in the past, the last one being the dinosaur. So the humans needs to be saved, right? And that is what we should understand. Just a second. So the term eco-friendly, it should be something like human-friendly, right? Because eco is always not an help. Now, what exactly can help us save humans or the other life forms? What we need to understand is everything which is driven in sustainability is because of the flow of capital or moves. Now, you must have heard that the companies have taken business model so strongly that they have taken care of the remaining aspects like natural systems or environmental systems, etc. And this thought process was developed in the 1970s by economist Michael Friedman, who said that the business of business is profits, and that's the whole reason which is driving the issues around sustainability. One of the key reasons. So, just to understand how business is sustainability, what we see, and this is a report in August, just 2 days back, this report has been released by Stanford, which says that the entry-level jobs have dropped by 30% since late 2022. Now, all of us understand that AI is going to take job hits, and this is a concrete data which has been exposed. So, how does this work on the SDGs? Now, companies spend capital on AI machines, which impacts SDG 13, which is climate action, which again impacts SDG 8, which is decent work. And what you can see is the inequalities keep increasing, like the Gini coefficient keeps on increasing. We said that how the inequality is actually shaped by the economic factors. Now that translates to SDG 12, the responsible reduction in consumption. Now we just heard a talk on plastics, and when you look at biodegradable plastics, etc., oftentimes the price is a big factor, and if the price coming to is not actually taken care of, then definitely impact the responsible reduction in consumption. We impact good health, and we also saw that in the previous session. So what you see here is right, and in some ways businesses are contributing to that. But there is positive news, right? Consistently. So by 2030, 30 million new jobs have been created. And if you see most renewable EV efficiency and nature solutions, and all the technical talks we heard today, in some way or other, lead to new jobs. Right? But that will require a very different way of thinking in terms of how we're going to approach these jobs. Right? Because not everyone understands how exactly things relate to economics of this. And we can always take on economics, right? So when you're a first year student, going for final year student, going for the interview, you need to kind of showcase the company why exactly you matter to them, right? And what skills would help you kind of navigate that. So you need to show a strong understanding of these domains, not just technology, right? So what is the positive spiral which can actually take things forward? Now, something at universities, what can be done is, what the practical look like, which would actually contribute to SDG8, but also rankings and research funds, right? And this is something we're going to touch upon today. So this is the agenda for, sorry, this was just the introduction. So this is what we will be covering today, challenges, academia, some of the dominant global frameworks, role of investors, government and academia, and as I said, we're just covering a very high level aspect on sustainability. It will uncover what are the factors which are not seen easily, but actually matter a lot in our transition. And then we talk about a few ways of industry partnerships, some examples from Principal Scientific Advisor, Government of India, and a CSR partnership which we are involved in. And then again, what frameworks will actually help us navigate this whole structure. So, about me, I'm 22 years in the industry. I did my BTech at NIT Suratgarh, mechanical. Then I worked at a startup. For Oracle, I was there around 10 years. And then I went to Oxford, and that's where I feel there was a real transformation in me. I got a paper on Open ESG, and that actually got me, connected to many of the people across the world who are actually framing the roots of the game, framing the ESG frameworks. And with them, through hundreds of meetings, I actually got to know what exactly is happening in the industry and where things are really moving. So after that, I joined an impact investment firm in London. I joined BTech, where I took the company from 0 users to 20 million users, partnered with Revenue, Express, Lloyds Bank, etc. And then how banks are thinking about finance, financial sector. And then my current company is Cancer, just trying to combine all my learnings and trying to offer what we got. So, Chief Scholar, Godavari, UK, and that gave me access to a lot of high-level, very effective, influential people who have got me navigate those bridges. And then again, some more aspects what I have done. But yeah, one thing I wanted to touch upon is the mission of which is led by Principal Scientific Advisor, Government of India, right? Which is the objective of that is to upgrade 1,000+ universities across India holistic upliftment of that. Right? And that's a very important project. So I've been part of the core support group committee, and my goal in that is focusing on sustainability. So what does the universities currently look like? Right? If you see the national parameters, we have tier 1, tier 2, tier 3, and there is a sharp decline between tier 1 versus tier 2 and tier 3. Right? So just for an example, if you see average CTC engagement, or if you see the grants received, patents for it, or eliminated work. So all these things actually contribute to one thing, that we do have great institutions at the top. When we go slightly below, that's where something is not right, something needs to be addressed. So, at PSC also did a lot of research on what exactly are the problems around these universities. And some of the aspects which was uncovered is the ones which are displayed on the screen. And I'll just give it a minute to see if this reflects on what's happening. And this was with almost 100 tier 2 and tier 3 universities. So when you see all these problems and try to solve a problem like this, there are so many problems that if you just try to solve one problem, you might just lose another. And think through a system thinking lens and think about what should be done. Everything, most of them together. So here is something for the academy, the way problems are looking at. And I'll just briefly talk about sustainability in the history of how things started in sustainability. In 1970, I spoke about Milton Friedman, and that's actually the current business power process. That the business of business is profit. But in 1990s, there's a people bottom line framework in CSR fund started growing. 2000 onwards, the ESG fund started funding to the investors. So investors funding the ESG funds. And when investors are holding the stock of your companies, it's pressurized to go green. Even today, company CEOs are paid based on the sustainability metrics, and that is something transformative. And that's why when you look at the job, job descriptions, even at the graduate level, you will see ESG is required, right? Because companies feel accustomed to it. In 2010, we touched upon a few frameworks, and I'm going to talk about these frameworks a little more in detail in the subsequent slide. 2015 Paris Agreement, we did have all the nations come together and talk about various agenda and limit warming below 2 degrees. 2022, we have the NP and government of India's approach towards sustainability integrating into education. And 2024, when the accounting period started, what we realized that we are far behind what we should be. So 2025 is what I'm saying that there is opportunity because institutional rankings have come into the focus and sustainability is the parameter in that. And the opportunity here is for institutions in leadership position, placements in research works unlocking this massive field of sustainability is actually unlocking trillions of dollars. Now we'll touch upon the global frameworks which we just briefly saw in the previous slide. And ESG as a concept has actually blown away out of proportion. Right? The total global assets under management is 140 trillion. Now what is assets under management? Now, if you or your parents or anybody is investing in mutual funds, say NTFC mutual fund or Tata mutual fund, they have so those are called assets under management. When actually a foreign institutional investor invests in the assets in the company stock. Now, how did ESG come into picture? Investors are very smart. They used to take 0.3 to 0.4 fund management fees. Right? And this was an opportunity. With ESG, they can start charging up to 0.8, 0.9% of charges. And that actually opened up a massive ecosystem of all these companies, what you see here. So it was started as a way to make additional fund managers. It was not intended for sustainability. But since that has happened and we are continuing, there is definitely solid progress happening in that front. But we need to understand that where it came from. Now, I just briefly touch upon this framework. These are the disclosure standards, global standards. In India, it's called BRSR. This is responsibility. Business, BR, business responsibility. And there is sustainability frameworks, the scorecards, aggregators, sector benchmarks, and then you look at these frameworks online because there's a plethora of information about each of this. Right? And this is actually driving the global markets. Now, why is it important, right? Now, globally, $40 trillion of funds available in sustainability, in private sustainability. But all the funds, impact funds, small impact investment, bonds, etc., they just add up to only $7 trillion. And that's not going to move the needle. So, this is something which we need to be aware of. This is something that things are changing. What I want to talk about is donor economics, which is 2012 by a Oxford professor K. Rao. And the concept here is we are living in a very tight situation. We have this social foundation where the minimum needs has to be met, right? The social equity, water, food, etc. Right? And each of these consumes carbon. And outside we have this nice planetary boundaries. Our nice planetary boundaries already you are already in the red. We have crossed that. So the concept is how to stay within the range and still be able to navigate without exceeding the boundaries. So now we'll talk a little bit about the role of investment and government. Now these are when I spoke about the investment landscape, these are the different investment available globally. There is impact and ESG focused funds, industrial climate funds, and corporate and strategic investors. And all of this is about it's a huge market. Right? Nothing, we have not seen this kind of scale earlier because it's more of an existential question, and everybody is just pulling in money, but the money means not channeled in the right purpose. But yeah, money is important. The second is the green bonds and green loans. We also have SBI green bonds, etc. A lot of local funds as well. And there is state climate fund, etc. For MSME, poverty credit. And then yes, government and public sector initiatives, green hydrogen, state management, ban certificate. Now, basically, companies are kind of achieve a minimum target, and they have to achieve these certificates and certificates. Right? And if they are not able to achieve, they lose the loan, they have to pay for that. And second, which we have seen in India, mission life. How many of you have heard about mission life? May I see a raise of hands, please? Okay, so that is what it explains. So we have just a couple of hands, and that explains basically the awareness level we have created. Mission was started by the Indian government around 5-6 years back. The idea was how you can bring about lifestyle changes in every individual. And what you see is it does not reach the masses. Obviously, when you taking up a eco-friendly action, that doesn't necessarily sometimes not convenient, sometimes it's expensive, so things are not scalable. So there is progress, but there are also opportunities. Now here is something you want to think about. This is the principal scientific advisor. We work closely with them, and so there is ecosystem where principal PhD works, and I think Professor from IIT Godavari, he may be also working with them already. So this is the ecosystem that works. So innovations from IIT top institutions are taken up by them, and this is COE steering committee, technical committee. They take up there is guideline on guided flow, and all of them are actually taking care about how does these innovations can be commercialized. Today, in university, the innovation is treated to PRL thing, which is just the initial pilot, etc. But how you can take it to market and scale? Because only when the innovation brings money, that's when it can be scaled. Right? So that's the approach they take. There is some innovation partner, theater partner, center led by women and its delivery officers, and they're targeting a different technology and livelihood, etc. What we do is we take case studies, and our goal is to distribute these case studies with as many partners as possible so that the innovation becomes much more visible. So now just about what is the transaction of this? How are we doing time? What are we doing time, sir?
5 more minutes.
Oh, so, partnership. So, all of us do have industry partnership. What you see is they're very transactional. They come to my area, take a few students and give. But what we also see and do understand that trends here because there are different available jobs, right? And that's something we need to be careful about. So, instead of being more reactive, we be proactive. On how can effective industry so instead of focusing on short term, we focus on long term and goals. And when you look about this approach, the placements ranking grants are the byproduct, not the focus. Then also need to focus on the CSR funds. In India, there is 60,000 crore CSR funds not often used. There's a huge pool of money available there. Not usually the current partnerships are the one way academic industry and academic, something which will work well is both with multidirectional all of us and longer partnerships. This project we're doing with one of the top in India. But about this example is very recent. Also, it's an example of why technology is just not about solving high-tech stuff, but also the everyday problems. Right? We saw this recent Supreme Court on state, and the There is a very common issue we see. It's not very easy to identify the dogs when they're vaccinated. Okay? And that's a lot of is already going to take companies in India. Through GLA. So we look at our phase. Our phase doesn't have it's good for human recognition, but for dogs and animals, it's a lot of data. And then we fix it, and it is pretty decent results. So yeah, I think with the better technology, and when you think about AI, we need to think about solving the problem, focusing on the problem, not on the technology. Because technology will keep changing. Once you understand the problem, that's where things start moving. So, how many of you have heard about the 4P platform, 4P framework in marketing? 4P in marketing: people, place, profit. What's the fourth one? Four P framework for academy. Sorry, we start first with the. So, what is request and it's something where community has to be embedded right in here, right? So that we start learning. The course. Automatically insert the specific data and it can actually bring forward the real good insights in terms of what's happening around the world. The second thing comes to projects. Right? Now we understand that publications are important, scientists are important, and that's go away. But the question is that we go forward with that, go forward to pilots and nations, pilots and policy market, policy how it being. Now, we look at this industry, but also tends to kind of think through policy because then the things start moving really quickly. And projects, if they're like aligned to industry, that's where things start moving. And third P is partnerships. So, as we spoke about the partnerships, transformational and industrial pilot government adoption NGOs were weak because the always the framework government. And the fourth P, the final P is pathway, and the most important. Right? How to materialize this? So short courses, usually deployment, especially for third and final year, international investments and to global hubs. And then the that's something which should be thought of because now the jobs are going to take a separate stage, right? Something it's a nature more clear focus. So here are some goals which we have been working on. Some are in pilots, some early development, but I want to share the goals with you. So curriculum for year one, we have been working with the university in and we are designing their curriculum for the first student working in India. The second is the initial development, turning the slide into automated, subsidiary integrated platforms or sites. And something which we have worked actively is increasing a book on sustainability. Hoping to launch that in September 2024, 2025, and we have collected almost 100 case studies from India, which definitely reflect on what's happening. Something sustainability is in very simple language, and it tells you why it is important what's really working. And this book is not for academia; it's also for policy industry. It's a multi-stakeholder book, so it has a very different direction. In the project, we have prepared this workshop for faculty if they want to tap into CSR funds. Student project, anything you want to explore about what kind of things are shaping up. And any of the current pilots which are happening in the university, and in fact, to our Taiwanese friends as well. So you can any of the case studies, so which you want to kind of bring forward to wider stakeholder policy, government, investors, etc. You will be happy to include that as well. And that will actually take the impact of the wider. Partnerships. Long-term driven, we should prepare short-term, long-term goals with government. And that's the kind of key way of doing the partnerships. And we'll be happy to have traditional partnerships. Your previous in the University in Bangalore, we are bringing experts from Godavari and IOC, and they are taking the actual things which are happening on the ground. Sorry. Our initiative, which actually push things really sharp. What we understand is there was also aspect of green campus. So what is green campus? What is exactly doing about each of these elements? And what we are working on is the platform where stakeholder can engage and start contributing to that. We are also offering short courses, digital development, and international immersion. So currently we are partnering with Oxford Cambridge, not university but some of the institutions there, but Oxford and Cambridge professors committee, and also institute in Germany. So this is what we have, and something like totally aligns with the theme of the conference where students travel to Taiwan and gain this rich experience on the Philippines. So, with the final slide and the last hurdle before lunch. So, when I graduated from Oxford, in my graduation, one of the things that he said actually stuck with me, which is what is that one thing that can be a North Star, right? That is justice. Justice for everyone. Now, if you have this thought actually stayed with us, and I will just put this in the presentation. So, yeah, that is all about us. Thank you for listening.
Thank you very much, sir. Now may I request Chairperson Dr. S. Raju to kindly felicitate our guest, Mr. Prakash Gupta, as a token of appreciation and honor.
Thank you, Prakash. Friends, the almost the presentation started with a message because he was about to intersect about the sustainability and green technologies. But sustainability is not meant for someone, it's not the responsibility for anyone else, but it is the responsibility of each and every individual. All these SDGs are going to create huge employability potential, employment potential. We clearly expect how does by 2030 the employment potential is going to happen. We nurture the importance, the challenges, and of course the opportunities and the academicians is regarding this SDGs. And one thing you to remember, I think, innovations are the right ways of the health creation. And obviously, let us see my students or researchers that our ideas must be in a position to get commercialized. So it's really so happy to have this presentation. So wonderful, sir. It is not with respect to any particular technology development or something else. It's a real practice what that they are following on their face. It's really wonderful. And thank you, sir. Prakash Gupta. Thank you so much. And I thank all the four speakers for their excellent speeches. And I thank our honorable Vice Chancellor, Dr. U. Chandrasekhar Garu, and all the organizing committee for giving this opportunity to have my presence as one of the required positions. Thank you so much. Now I request Dr.
So thank you so much, sir. Good afternoon, all, and we are proceeding with the validation session, which will last for around 15 minutes. Please bear with us. So I request our honorable Vice Chancellor, Dr. Sir, to come on to the dais. I request Professor Lun J. Yang from TECC to come on to the dais. I request Professor Chen Chuang from National Sun Yat-sen University to come on to the dais. And I also request my good friend Dr. S. Shivaperumal, Pro Vice Chancellor of Presidency University, to be on the dais. So as you all are aware that we have started our program officially on the Ganesh Chaturthi Day. So the third day we are in this program, and we welcome the guests on the day one, and we had Sri Road, followed by technical sessions yesterday and today. We had a lot of speakers who have been here giving a lot of inputs on various aspects pertaining to sustainable development goals. Now it's time for us to do a validatory program so that we can understand and conclude what has happened in the last 2 days in a nutshell. In this regard, I take privilege in asking our Vice Chancellor, Sir, to come and deliver his remarks.
Good afternoon to all of you. Indeed, it's a matter of immense pleasure and privilege for all of us to host this event in our campus. As has been explained by Dr. Murli, there was a Ganesha National Festival related holiday day before yesterday. There was tremendous involvement from the faculty members, HODs, professors, principals, and student volunteers who participated in making this event happen with all the sincerity. They were working until almost 10 o'clock in the night. Big round of applause for them. They came on a holiday, they stayed, they took care of the all arrangements, they contacted the speakers, they contacted the transport people, they contacted the decorators, and everything was in place when we came yesterday in the morning. So, really grateful to all of them for making this happen. Professor Yang and his team at NSTC has been responsible for guiding the team of Godavari Global University for almost 4 or 5 months continuously, giving the inputs and giving us the contact details of the speakers from India and abroad. Professor Yang, this event has happened only because of the continuous support from you and your office. Thank you so much. Professor Chen Sing Chuang, we met briefly when we came to Taiwan about a year ago, and when the call came for this particular international conference, immediately you said yes, and thank you so much. And we had only a few days, and in spite of that, we could fill and submit it. Only one day. Yeah.
So thank you so much for that. I called Professor Shiva as a representative of all the speakers. We had extraordinary speakers from IITs, IISc, industries, a couple of universities. So on behalf of all the speakers, I'm sure you enjoyed it for hospitality, and there could have been some kind of lacuna here and there, because this is the first ever time we are doing an international conference of this kind in Rajahmundry. So if there are any mistakes, please apologize for the same. And I'm very sure that there are many useful takeaways and pathways for all of us from this particular conference. And we sincerely look forward to being in touch with you and making sure that some of the envisioned outcomes of the conference are crystallized into realities. Thank you so much.
So we thank our Honorable Vice Chancellor who has put the seed of bringing international conference to this campus and bringing 12 international eminent personalities on a single platform is a tremendous job, sir. Thank you so much for presenting it, and a round of applause to Godavari Minister. Now I would like to call upon from TCC to give his words of gesture.
Dr. Yuzi, all the participants and all the delegates from India and Taiwan. Firstly, I want to appreciate all the help and preparation, all the help from the GGU design. Actually, I just remember when we started about the preparation of this conference. Actually, you see, I in my office, and we just talked about with the coordinator of the conference. And you see, you suggest Mr. John did from the NFC. So I say university is quite good. So I just called the phone to the Mr. John. He just think about 1 second and say yes again. So we start. So this cooperation actually is very organic. It's very organic. It's not, in Taiwan, we talk about the semiconductor, right? Right now, everybody agrees semiconductor is very strong in Taiwan, but semiconductor is an inorganic material. It's an inorganic material. And found a lot of talks in these 2 days. We can see many talks related on organics, especially in India. Everything is a green energy, everywhere. Especially the topics, the green economy, sustainable development courses, AI for green technology. Not in the something worse. Actually, this topic is discussed by us. After several rounds of discussion, we decide the topics of this conference. But in the conclusive manner, I can see organic is very important keywords in this conference. I have the thinking, when you see invite me to have the 5-minute closing remark, just think about what I should talk. So I just think about maybe in the following, we keep cooperating, okay? But we should keep do this kind of manner in organic manner. Organic manner means that it's for the life. It's for the, it's not the design our purpose, but it should be according to the humanity, according to our heart desire. So I think it's just very spiritual, not exactly the scientific and scientific technology only. So I think, I'm also touched about this. So I'm very touched about this. Even in the scientific technology field, in the past, people think about the silicon-based technology, right? But silicon-based right now they become goals here. Right now, nanometer scale, we have saturation wall over there, we cannot break through, right? But in the organic way, for example, carbon-based material technology, maybe have in the future very promising and underdeveloped.
Yeah. So so I think as the director of science technology in the TCC, I often think about, okay, maybe we have some mission we need to do right away. Yeah, maybe this year we have some input project we need to log and proposal and review, and that's all the PR to go, whatever. But we need to think about just a burden that maybe we can have many friends here, right? Work together towards the goal about organic matter. How to organically to coordinate all the people who friends in India and Taiwan get together towards to more lifestyle cooperation. I think because a lot of resources are very limited, a lot of limited. But if we have a good heart, good organic friendship over here, we can break through all kinds of difficulty and keep going our idea. The real friendship and the real. Thank you so much. Yeah, thank you so much. Yeah, hope to see you soon, everybody, and look forward to the young people. You also can join us in the future. Okay, thank you so much for your help and participation.
Thank you, Professor Lang J. Yang, for your wonderful words. And definitely, our relationship will be more of organic than inorganic. Now, I would like to call upon Professor Chang, who I met on 27th in Delhi airport, and we spent a couple of hours before boarding the flight from Hyderabad. So where I was just talking to him within 10 minutes of my decision with him. The first thing he told, next year how many students from your university are coming to my internship program. That's the kind of achievements. And I call upon, because there's our post university, it's what National Sun at State University, you can see on the top. He's from that university, and I would like to call upon him and give his gesture of words.
Okay, thank you, Reddy. And as two important persons already mentioned, how this conference happened. Okay, so actually, UC and the president, they come to my university and I arranged a hotel. I remember that, and we show our laboratory and the beautiful campus, and I really appreciate your visit. So when Professor Yang told me, I said no problem. If UC want me to do it, I will do it. Okay, so in these 2 days, I really appreciate all the speakers give us very fruitful ideas and results and inspire us. Like Professor Yang just mentioned, in organic material actually is really important. And in our lab, we also doing all organic materials. So I really appreciate you see about hospitality. I really enjoy these 2 days in this city and GGU campus. Okay, so as professors mentioned, that we already have a lot of Indo and Taiwan collaboration project. So I think in the next year we're gonna open a few projects for the GGU students. So we're coming to come to Taiwan and experience maybe just a few months, but you're gonna have many benefits in your lifetime. Okay. So I really, in the next, I want to thank Dr. Jiba is here.
Jiba.
No.
Still working on.
Okay, so because I really appreciate, although I'm the one of the coordinators, but my effort is very less. All the effort is doing by Dr. Jiba. Another I would like to appreciate is Miss Eva. Yeah. She is the Taiwan side coordinator. Okay. So the most important is I want to thank all the participants, students, and faculty members. Thank you for your humbling experience. Thank you. I will see you in Taiwan. Okay.
Thank you so much, Professor Chong, for your kind words towards our faculty and, of course, our students. Now it's time to hear from Dr. S. Shogarma, Pro VC of Presidency University, about his stay in the last couple of days on the campus.
Thank you. Really enjoyed visiting GGU, and thank you for the great hospitality. Maybe coordinating such a mega event, having maybe more than 10 speakers from Taiwan and various part of the country from India is not an easy job, really, which I've gone through many times. I think I said both the professors sitting on stage from Taiwan, one from Taipei, top of the Taiwan, one from San who's bottom of the Taiwan. I think geographically, entire Taiwan was covered by various speakers from various places in Taiwan. I think, as I said, coordinating such a large number of speakers is not an easy. I think GGU did a great job. Thanks to UC sir, Professor Yang. I think both the coordinators, as Professor Chong mentioned, Shiva as well as Deva, are coordinating such a great. Really, we had a great 2 days. Really enjoyed. The speakers, I was really amazed yesterday. Some of the topics which they covered today. Some of the topics we listened to robotics to agricultural to maybe water, underwater, or various topics. What was covered really was something which is incredible. I think all of us should work together and make this sustainability as our goal. So thank you very much for the great opportunity. We really enjoyed the 2 days of learning. Thank you very much.
Thank you so much, Shivadar. And of course, Shivadar was there in the BP seminar hall where we addressed around 100 plus students, and he has inspired them to go to the international education where free scholarships are available. And he is very happy to help GGU campus on for immediate input on how to go to foreign countries for international education, where the financial burden will be very, very, very limited to the students. So thank you so much for your inputs. Now I would like to call on the participants who came from outside to collect their certificates. Professor M. Balakrishna, here please, Professor. I request Dan to do the presentation. Professor C. Venkatrao. Professor Y. Vijayasri. Professor Shehnaz. Professor Mahita.
Thank you so much, sir.
Thank you.
Formally, we conclude the section 5, and thank you. We look forward for seeing you in the subsequent sections. Thank you so much, sir.
Jai